Are we live? Am I live? Hello, wonderful people. Okay. Guten Tag and hello. Oh wow, we have a ton of people already in the chat. Let's take a look. I'm a little bit unorganized. I spent a lot of time preparing the food today and not preparing the projects. But you people decide today which project we do. So we have Roland, Mr. Who. My Name ist Luni, bitluni. Ray, Maiko, Johnny is here, Quinn, Roter Fruchtzwerg, Embedded Hobbyist, Crafter Games, Andy, Mr. Who. Okay, everyone. We greeted everyone. Sniff, ESC, Crazy, Kraschi. Oh man. Hello, Aaron. And Alex is also here. Tiny LED matrix. Okay, so new format today. Aaron suggested it, and I thought, okay, let's do it. Let's try it on the Trash channel first. I announced it already, but on the Trash channel first, and then let's get my list of projects done. Hello, Quindor. And maybe some interesting projects that you vote on. So for sure, because the winning projects, we need a pitch of projects that we can do. I prepared 3, if I find the parts. And everyone here in the chat can vote on those. And like, after we decided on the candidates. Oh man. Okay, let me prepare everything. How is the sound? I actually don't know. I have only one microphone today because I disassembled my my other microphone because of some noise that it's generating right now, and I'm not sure what's the cause there yet. Okay, it's fine. That's good. Good to hear. Sound is great. Okay, wonderful. Let's introduce the food today. We have the fondue, classic. I will increase the temperature. We have some mixed bread today. So we have baguette, white bread, and some really fresh crusty bread here. Very tasty. German bread. And we have Mettbrötchen, that's like our German dish with onions. And I'm really hungry because I didn't have lunch today, so I will just grab, until the fondue is ready, I will grab the Mettbrötchen. Hello, Dustin. Yes, Met is Wurst. Mettwurst. Okay, so do you have project suggestions? I have. Let me show the screen capture. I should switch the screens. The OBS over here, chat over here, so I'm more looking at the camera here. Where is my screen capture? Here. Oh wait, I have a green screen in the background. Let me turn that off. Where are the filters? Filter, chroma key. Turn it off. Okay. Now the noise is gone now. Ay, ay, ay. Okay, so this is my screen capture. Oh no, I showed the link. Don't vote yet. Don't vote. So what do we have? We can. Oh, this is not. We need to edit it. Do we edit? Yeah, we can. Okay, so the first choice I prepared is the flip.accident counter. So we had suggestions on Discord. So I got. Oh, I can maybe show that. Jakob, which is a viewer and a great supporter, since he sent me some really cool stuff. So we have this flip dot matrix, and oops, something just fell off here. I hope that it wasn't a part of the flip dot. Okay, so we have a flip dot and some driver ICs and a nice note which indicates how it's done. So we can actually make a counter which counts how many days since the last accident in my lab is. Yeah, I have a flip top. I got this donated by Jakob. This is. I don't know if I can show where he's from, but this is the nice note. It's like, yeah, with some ICs and so on. That's yeah, and some links that I have to type of. So we have the flip dot already. Flip dot accident counter. Screen capture. We had on Discord a suggestion that we can add some audio, like a huge button to press, and then the counter is reset and we get a Wilhelm scream. And I can use, actually, I could reuse like an old project. Oh yeah, we have this audio amplifier unit here that I used for my last Halloween project. Here, this thing. So, what did I use? Was it ESP32? Yes, I think it was. So we have some parts here, actually. Then, next thing is MIDI on a flute device. So, but I have a problem right now. For the preparations, I was searching my lab for the flute, since I bought one specifically for this project, and I can't find it right now. I have always like a huge mess in my lab, and it might be like risky to build this because I don't. It's a single or binary display. How is it binary? I think it's. I don't know. Dustin, you have to work us through that. So the the MIDI on a flute device, that will be complicated because we need to get the airflow. We need like a MIDI device, and then play from the PC to the flute, add some servos, maybe with hot glue, because we can't 3D print in time anything today. And then the software should basically play really wonky, like the 20th Century Fox on a flute. If you didn't see this meme, search it on YouTube and watch it. This is something that we would like to have with like any MIDI notes. So Henrik, I'm like pitching the ideas that I brought today, but I want your ideas here. Burning 3D printer CO2 extinguisher. So this is another one. That's an easy one. We might even, I don't know if you like to have an easy one or if you want to torture me the first episode, so I give up. Where's the turn that off? Okay, so this is something I have the parts for ages here. It's a nice thing. I give away everything, like my secret projects that I use. This is like a bicycle pump. You can get this like really cheap from AliExpress and such. So it's like basic thing here, and you put in cartridges like that. So you put them in. They are like these are like CO2 cartridges, and if it would focus, yeah, here. So this is punctured here, the top, by this, and there is a seal. I don't know how tight the seal is, so for how long that would actually last if it's like armed. But basically, I can take this off. Basically, there is like this vent here, and if you open it, then the CO2 comes out this way here. So you can basically mount this, use like a servo on top of here, and then some kind of detection, fire detection, temperature, maybe smoke detector or something. We can maybe reuse an old project. And then it will basically extinguish if something is on fire with CO2. Super basic project. We have like several tries here. And I would need to set something on fire here. I don't know, might be dangerous. But these are like my 3 projects that I pitched. But disclaimer, I'm not sure if I can find the flute because I'm so chaotic. It could be anywhere here. I had it on like a sideboard for months now. And recently I seem have to tidy up so I can't find it anymore. Mettbrötchen and fondue, yeah. So just to clarify, how many 3D printers did you set on fire so far? None yet, but I'm scared of thermal runaways when I'm not present at home or something. I hope it isn't too loud when I eat. How's the fondue? Oh yeah, the cheese is melting. So, now I want you to vote for CO2. You can vote soon on the sheet. I will give you the link when the vote starts. Not yet. I want your suggestions now, please. I will fill the form with more stuff, but I need your project that you add an option here. My thesis was on, yes, I built a 3D printer myself, which is like dual extrusion printer, because you couldn't buy cheap back then like any printer at all that could do dual extrusion, to print like embedded electronics in 3D prints. So I had like an extension I wrote an extension for Blender that basically added touchpads beneath the surface of any shape, and you can basically attach them to an Arduino and it would sense the point on the structure where you touched it. Okay. I see no projects with pink LEDs. Okay. Let's start. Why not make a catapult that throws the 3D printer out the window if there is a fire? Is this a suggestion, Station 240? Is this a project suggestion? 3D printer catapult. I'm against destructive stuff, so I want constructive projects here, but we could take a vote. I would discourage it. Accident, okay. We will add pink LEDs to anything that we make, so no worries about that. Automatic fondue maker, but how, Anshi, how does it look like, the automatic fondue maker? Bad delay? Oh no. Okay, sorry, I reading back, so I didn't, the stream, the chat is fast today. I had like bachelor and master thesis, no PhD. Automatic fondue, okay, fondue stir maker, okay, fondue stirrer maker. What tag do you want to use? Seth, any tag you like me to use. We will make it, we will try doing it together. Add automated steer bar gun for bicycles to one-shot a low distance overtake. Okay, no guns. I'm a pacifist. No guns here, but we can steer bar gun-like sound device to one-shot at low distance overtaking car. Yeah, very illegal. I don't know how we will film something like that here. Maybe a device that shows a face of your favorite streamer on that flip dot display. Okay, no, not ping pong, the game, just meaning the ping pong LED wall with some kind of live tech interactivity. Yeah, live chat interactivity. Sorry, but Let me add my face here. I must admit that my... Where's... Oh, this here. The LED wall isn't connected right now, so we have one here, but there is no power attached, no microcontroller, no nothing. So that would take too long for today. Combine multiple ESP32S processing power to control a single high definition display. Marco, actually that could work if you like if you have like a shift in the clock, because we are really like restricted by the clock, not by the throughput. VGA hell device. How, Michael, how does your hell device look? Okay, YouTube chat controlled fondue heater heats fondue based on... Okay, I will add that. I might want to somehow change the... I don't want mine to be like on the top here. Okay, next one. Fondue heater. What? I'm not ignoring anything. I have like... We have like super fast chat. You speak 32 with a laser. I think the only lasers that I got are UV lasers. I'm not sure if you can see them, but they might be harmful. I don't have a green laser or anything. ESP32 VGA oscilloscope. Oh, that sounds interesting, but it will end up like being a digital oscilloscope, because there is no way you get a clean signal on the ESP32. Or maybe if we are using like an external device to do it. Maybe we can use RP2040 for that. I will add the multimeter function to the oscilloscope. First microcontroller with built-in wireless charger to charge LiPo battery. I will add this. But we have only like CO2 ping pong ball launcher with ESP cam controller. This is a one stream thing. So we can either build the launcher today. Oh! I will add that. Vote is in a few minutes. Okay. Last chance. We have like 4 minutes for the votes. Okay. Flip dot oscilloscope. I need to add this. This is cool. Flip dot oscilloscope. This is like this will be like featured on any hacker online magazine if we do this on a 24-hour stream. Oh, I don't plan to do 24 hours, or I have to recharge. Oh, I think I have even recharged some more batteries for my microphone. But the CO2 ping pong ball launcher sounds great. Yeah, I would add this like the last one, because that sounds like something that we can Rickroll. Okay, automatic Rickroll machine with pink LEDs. I will add this. Okay, this is the last one. Desktop ESP and servo robot vacuum tiny. Oh no! Now the ideas are rolling, guys. Okay. Tiny for the desktop. This is so cool. I will add this. Flip dot multimeter. Oh yes. I will make it. Okay, we need to get the multimeter thingy. Stable programmable DC power supply charger. Oh, Rizwan, I'm not sure if we can make this. This is like, that sounds. I don't know if I have anything that could do that. Accident power counter. Okay. Combine Rickroll machine with accident counter. Okay. Done for now. Suggestions are finished. This is, I will move my thingies to the bottom. I have a personal favorite that I will vote on. Where is it? Flip dot. Okay, I will leave the accident counter because that was like not my own idea. Extinguisher to the bottom. Like that. Multiple choice. Is this multiple choice? Yeah, whatever. Okay. Send, and I will copy the link, shorten the URL. Here you go. Vote now. I will give it 5 minutes for the vote here. So, and 19, 34 and 45 seconds. Oh, you can see this. Shoot. Can I move this? No, I can show the clock. So, voting now. Okay. Yeah, okay. Oh, we have 11 responses already. This is cool. Okay, I will hide what I vote for, because I need to vote as well. People, vote. Vote now for the project of your liking. Please don't exploit the voting thing here. I need to do a vote myself. So it's a hard decision. I like it all. Okay, I can imagine the ping pong ball launcher. You can make it chat controlled. So the chat could like use Brian's library, exclamation mark, left, right, and we have like a servo up and down, and then fire, and it would launch a ping pong ball, and we can use like a tube from like a toilet paper tube or something. But how do we? It must be like super quick. It's a hard one. It's a hard one. I think I will vote for another, but I like that idea. I vote for something. Okay, I voted. Submit. We have still 2 minutes. 2 minutes for voting. What stage? Brian, we are voting. Brian, you need to vote. Vote right now. Only 1 vote per person. Forbidden to vote twice. No. No, you can't vote multiple times. If you cheat, I will enable for you to have to register to do this. Like email address. No cheating. Don't do it. I think the fondue is ready. I need to try. Oh man, that will be hard today. My lab is still a mess. I won't find anything, and my 3D printers aren't calibrated. I brought one in over there, but I think I need to calibrate. If we need to print anything, we have to design it right away, calibrate and print, so it's ready when we need it. A little bit more. It's not hot enough. Mm. 36 watching. Okay. I think the time, oh no, it's still 20 seconds. 20 seconds left. How do I, oh no, 107. Maiko, the vote is secret. How do I close the vote? I will just open it. Friends, I see many votes. 111 votes. 112. What are you doing? Okay, votes are over. Ha! Here. Where is the screen capture? No! Stop voting! Ah, not accepting responses. Okay, cool. I turned it off. Where is the screen capture? Here, face off. Okay. So, no! What is that? What? Tiny desktop ESP and servo robot vacuum. I have no clue what's meant by that, but we have to build it. Flip.accident counter, 15 votes. Flip.oscilloscope. I like that. I must admit, I like that very much. So the flip dot thingies, What the desktop ESP? Who? What? 41 watching, 111 votes. Oh. Yeah, flip dot. What? No. Oh. 30 votes. Okay, so flip dot it is. Dave. Okay, Dave. I promise you we will make this project at some point. I have to improve my voting process. Go stand in the corner. Okay, so 30 votes removing. Okay, then it's like 11, but we have 21. Okay, flip dot oscilloscope wins. The people don't want the accident counter, they want an oscilloscope. Okay, so let's start. Here are the parts. Oh, I will look up the parts. Let me make my face smaller. This is not my face. Whenever I click on this stupid OBS window, I have no scenes prepared, so please don't judge me. I need to type TBD 62783. Oh yeah, gate driver. Yeah, we have that one. Is that one? Yes, we got 1, 2, and then we have, what is this? TBD. Aaron, we will do it with the desktop vacuum at some point. No worries. Cheaters, next time I will require for you to actually log in with Google. Sorry. I trusted you and you failed me. Okay, I need the data sheet here. And next part that we need is TPIC 6B 595. So this is the other one. Select. I hope that's the one. Okay, so I will give you. Oh, that's a shift register, and this is the driver. I give you the links here. I need to get familiar with that first. I hope that works. Oh, how do I know the components? I got a letter with the flip dot and the ICs here. So I have, if anyone wants to know what I got here, oh wow. Maybe we can, there are some tutorials, but I don't know, I can't maybe, so here are the details of that one. Oh wait, I have a zoom here, like a, no, it's oh no, it's completely zoomed in already. So there is an A16C25. And then this odd connector that you can't get. So we might need to somehow interface this. And then we have a bunch of little transistors or something there. And this is the side of the flip dot. If we can hide my face. And this is the front. And they are like, they're not stable, I think. I don't know. Yeah. We probably need to somehow power them. Oh, wow. These 595 are open drain outputs. They are used on LED matrix displays too. Okay, Looney Gate. Oh, add some label. You can have access to make a poll directly in YouTube chat. I've seen other channels do it. Oh, yeah, okay. I should do that as well. Oh, we have a poll here. Oh! Oh, I see. I see. Oops. Here. Oh man, I missed it. Here, there is a poll. Do you see it? I don't see it. Oh, but that was a quick one. No, people are still voting. Interesting. Oh, and I can end this at any point. That's interesting. Ja, nein, oink. Okay. I will end it now. Where are the results? Can I see the results anywhere? I think the result was, oh yeah. Fix the poll next time, yeah. Much better. Yeah, okay, we will use it next time. So, how do we not break this nice flip dot? I have some, there is a GitHub repository. Okay, now GitHub. Carl Raymond, Anax flip dot driver. Okay, I will check all the links now and give them to you. Carl Raymond, Annex lib dot driver now I need to add this this thing, the text building phase I need some okay, here we go. That's the wrong one. Where do I add it? Hello Photochromax, you missed the vote. The vote was 100% legit, not stolen. The vote wasn't stolen. Antifa stole the vote. Oh, wow, okay. Yeah, that's actual. Oh, and we have to rebuild this on the breadboard right now and run it? Oh, shoot. ESP32, oh wow, that's nice, okay. Column driver PC board. A span of panels can any length. One row driver daisy chains up. Robots. Looks like a fast and easy project. Oh no! Okay. First goal. I will at first goal flip a dot. Okay, I will edit. Goal 1, and then let me. Where is the building phase? Stretch, goal. Is it spelled correctly? Stretch? Stretch goal. This is gonna be a mess. Okay, I need a breadboard. We got a breadboard here. I have no clue how this works. Windoor. Yeah, it's a very common name. Everything good. No, sorry. "33 hours of stream left." Flip it. Okay, so we need additional links. Okay, so this is like OneDrive. Okay, you need the links. We have a challenge here. Then we have YouTube. Oh yeah, okay. So I need to type this. It's like YouTube. Watch equals V 4K underscore 9W underscore 0G7Q8. This is the first one. Oh yeah, Flipmaster. Okay, this one is running. There are like two broken dots. Oh, that's fast. Okay, we can do an oscilloscope. Okay. Okay, I didn't know the 9000 yet, so I will subscribe and like already. And now let's take a look if we can find
LED under each dot. You can see it there if I flip it up. Little guy, little green guy. And I think the way this worked is the LEDs were always lit all the time, and the circuitry up here is about...
oh, there are even integrated LEDs. Not in this one, I think.
When the dot would be open, you could see the LED.
Okay, I don't have the LED here.
And if I want to flip it in the other direction, what I've got to do is put a positive on the column line here, and then a negative voltage down on the row. There'll be no voltage up there anymore. And you can see that the current can flow down here through the coil, through the lower diode, out that way, and there's no way it's going to be able to flow up through any of the other diodes here. So it turns out you have 2 lines for every row. So since I've got...
We can learn something here.
32 lines, 16 high lines and 16 low lines. And so
okay,
1 line for every column. So I've got 30 column lines. And so they use these 40-pin connectors up here. And the first 30 over here on the column connector. Yes, it is. On the column,
okay, it's not similar. It's not like super...
And over here on the row connector, there's a high line and a low line for each one. The extra pins, I think, on this guy don't go anywhere at all. The extra pins on this guy go to these ICs to drive the LEDs. So
okay.
Let's try flipping some dots here. So I'm going to use a bench power supply here.
Bench power supply.
Set up for 24 volts. And I've also got a current limit on there. If you're just experimenting with one of these boards, you want to limit your current so you don't inadvertently smoke out one of your coils here. So
24 volts.
And you can see it's limiting to about 200 milliamps. That's plenty enough to flip the coils, but not enough to cause any trouble here. So let's put you down there.
Yeah, Fruchtzweck, I think as well.
Put myself on a stool here, and we will flip some dots. So if I want to go from black to yellow, I've got to put positive on the
I
row
can
line,
maybe
on the column line.
make
So
the audio better for you.
The one way over here in this corner. So that's first row.
No.
So
Can you hear it?
on the row 1 high line,
Okay, so
boom. All it just takes is
I hope you don't have echo.
So now let's flip it back the other way. So I'm just going to swap the probes. I'm going to put the negative on that pin and positive over here. Oops. Oh, come on. What's going on? I've got to put negative on the low line. That's right. Like I just explained, there's two different lines on the row side. You want to put the positive, you got to go in the top row. For the negative, you got to go in the bottom row here. So now let's see what we can do if we want to flip a whole bunch at once. So I'm going to pick a random line over here and doom. So I got every other pixel flipped because I ran along the top of the connector here. If I go along the bottom, we'll get all the rest. So that's a lot of fun. Now,
Oh, wow.
it doesn't take very long to flip the dot. You normally only need to energize this for a period of, I've experimented with this, and microseconds is enough. Oops, if I want to turn those guys off again, let's see, that's 1, 2, 3. So I need to be there. Boom. And 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And whoops.
Okay. We can experiment. The echo, okay? No echo for you. We have echo. Okay, sorry. So 24 volts, 200 milliamps. Let's test it. I will turn down a little bit my Fondue. And I will move to the bench and we will try to do a similar thing here. Oh, Jesus, so hot. Accident counter is reset to 0. I burned myself with hot cheese. Echo? What echo? Is audio good again? I'm sorry. Okay, so the counter would have increased the count of accidents or the time since last accident. You never know. Okay, let's turn on the GH5 over there. Turn off the screen capture and move over here. Okay, let's analyze here. I will move the camera over so you actually, sorry, don't get dizzy. Oh! Sorry. This tripod. Give me a break. Why can't I lock it right now? Okay, now it's locked. Oops, Fondue can. Sorry. What am I doing here? This is like, no, this is wrong. Sorry. Okay. I just want you to be able to see what's happening there. Okay. How many bitlunis? Okay. Okay, this is let's take a look. So we have XP, XO, NML. There are some markings. So this is 0, and the X 0, and the Y 0. So these are the row pins. Oops, here. Let's take a look at this section here. So we have here Y0, 1, 2, 3, numbering, and X, and so on. Now let's take a look at the columns. How does this work here? I'll take a look where this pin is coming. Okay, this is directly going to the flip dot. So all the through hole thingies are the flip dots. Then we have one complete row that goes around here. So, and now a second one, which is in the center. And we need to okay, we can't see what's on this side actually, but we can see from the traces here at the connector. I'm not sure if you can see, but we have some thin traces and thick traces. Here, these are all the thick traces and these are the thin traces. And we have this seems to be like interesting. Yeah, these are connected. These are all connected because it seems are they? I don't know. It looks like these are some pads, test pads. But we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 16 of the thin ones at the beginning, and then we have a bunch of thick ones over here. Let me turn it over. So the thick ones seem to be okay. How many do we have? What resolution is this? 16 by 25. Okay, so we have 16 rows here. Okay, 16 and 25 columns. I guess the 2 by 8 on the left area are the rows. Yes. No, it's actually 25 by... These are like, you can see the groups. We have a column groups here, which seem to be like 5. And we have 5 of those, and these are actually 16 rows. Okay, we can basically just flip some dots. Oh man, this is completely molten here. I need a new probes here. I will try to flip anything. I will set the voltage to 12 volt first. Don't want to go and 100 milliamps. Okay. Oops. The video said it was 24, but I'm not sure about that. I don't want to break it. Let me check again. Let's check if we can basically power a coil first. How do we test this? I can't see the coils needing much power. That's why I set the limits to 100 milliamps right now. We'll test the first dot there. Okay. And now flip it back. Okay. Let's try again. Was it this way around? Yeah. And this way around back. Okay. So 12 volts are enough here. Seem to be enough. We can maybe even go, I will try with 5 volts. Imagine we can drive it with 5. That would be awesome. Oh, yeah, it's slower, but 5 volts are enough. This is 5 volts. Dudes, look at this. 5 volts. And current is 100 milliamps. I can try to set the current to 20 milliamps. Oops. That's basically a death of a microcontroller. But if we can do this, then we don't need any drivers at all. We make it live. But I don't think that will work. It's like really, it will die because we need, yeah, no. There's nothing happening here. Oh, yeah, it was enough. But this voltage spike will basically kill everything. I don't want to. It's a coil. We don't want to attach a coil to a microcontroller, don't we? Try 1 volt. Try 3 volts. "96 volts, 100 hertz display." That's probably the output capacitor. Oh yeah, that's true. Oh. They don't look modern. They're like, the PCB looks like 90s. It looks like one of the public transportation displays when I went to school. How do you add diodes? Okay, we can add Zener diodes. But basically, how we can add diodes if we are flipping the direction? We can just do Zener diode. I will try 3 volts. But basically, Fruchtzweck is right. We have like a huge output capacitor. Three volts are not enough. Okay, let's find the wiring here. So, what? We have basically these are the column lines. No. Oh, strange. The first one is connected to the upper connection here, and the second is to the right. I don't know if you can see this. It's alternating here. Is it maybe because these are like mounted differently? No. Strange. These all are alternating. Oh. Probably they would affect each other if not. So, or it's basically, that's the X column. I'm not sure. We will see. Let's probe it. I need some pins. The Eurocard connector smells like kind of early 90s, yeah. Uh-oh. 1 hour elapsed. Row low, row high are the ones exiting the diode package, I guess. The physical rows are interlaced. Yeah, it seems like it's alternating each pixel. Might be a diagonal pattern, or not a diagonal, it's like a grid. Let's try quick and dirty first, and then improve. Iterative designs. We want to be SpaceX here. Even okay, I might not have a ton of relays, but if we had to, I would use a relay to be on the safe side with the voltage spikes and so on. I don't have enough Zener diodes, I think. So basically, oh, that one looks like messed up a little bit. You can see here there is some gunk, solder gunk. Okay, how do we find anything here? Let's find wait a second. How is this even? Let me zoom out. I don't even know what to start probing here. Yeah, okay, that's not never gonna happen here. I need this one here. Okay, and whoops. Interesting. Okay, this is, yeah, okay, you can see. How do we mark this even? I have no idea. So this one is here, and that one is somewhere here. This one. 6, 7, 8, 9, 10. And okay, this is the row, and this is the other pin. Okay, now let's try that one here. Okay, and that one, and that one. Okay, that makes sense. Dupont wires, I will try. But I think it's too loose. I will basically take the iron and solder anything here. Okay. Oh, it seems to work. Maybe I should use color codes. It seems to work. Yeah. Okay, Dupont is working here. So how about we use male connectors here? Like, oh, female connectors, like these here. Is the distance okay? Oh yeah, that should work. Nice, okay. Let's interface first. I need to see how many we need. So this is the first one. I guess the last one will be like 4, 8. Yeah. And that one will be somewhere else. Okay, this was 8. Okay, we need 2 times 8. These will be the row pins, at least one side of the row pins. Why do we have? Do I have a bag of male connectors here? Okay, first one. It actually fits. Whoo, nice. I can solder to these here. And then use like, oh, there might be even a space, a space in between that might fit a breadboard. Let me check. Or at least a perf board here. Look at this. Will that work? No. I need a long one. Ah. That's not long enough for the complete thing here. Okay, let's find the other ones. So these are the first row set. We have the second thing here. That starts somewhere here probably. Where was it? Here. Oh. That's like ground pins. Yeah. We saw that on the other side. These are like, oh yeah. Okay. That's the traces that we saw before. So we have the 8 that are here, that are relevant. Then we have the super thick one. That seems like to be a common ground or whatever. Or yeah, inverting, clearing, or one huge pin, or 4 pins in this case. So we might want to use different male connectors with 10 pins each. So I have 10 pin connectors. No. Okay, how do we find out the columns now? I will read. Pink headers. Interlaced. Okay. Pin out of the connector. Yeah, I will. We will do it. Proto board. Yeah, it's 32 by 3. That will proto board will fit. This connector not soldered on. What? I missed the chat a little bit. I have no clue what you're talking about. Okay, let's take a look at the front. We have 3 here. Okay, I need to count where we have the columns here. These 4 are connected. This is one thing. 20. We have 25. Oh, this one seems to be... Not all are connected probably. I have no clue. Let me check that. Oops. Let me check what's happening here. Okay. So that's what I saw there. Let me oh no. I forgot my pliers in the car. Shoot. Okay, so we got like which one? You know what? I will just take the whole thing here, pull this out. Oh shit. Okay. Let's remove the shorts. Okay. I will just take the complete row. We need to find something to solder this on. I might not have a perf board that's long enough. No, doesn't look like I have. The only ones that would fit have no connections whatsoever. We can maybe prototype. Do I really not have anything here? Have something like that. It's almost there. Oh no! It's almost there. Or we use like this as a huge connector and solder on the back side like wires or something, but I don't like that. I don't like this at all. Eight and at least one. I don't pull out the mini mill right now. That would be also an option. Or we just make a connector here. Let's make a connector. Okay. Let me cut this. This will be enough, yeah. This will be one connector, I think. Why did I... Okay, whatever. I'm not even sure why I cut it there. I rather need to cut like one row here. Are these connected through? Yeah, these are connected. Okay, I need only one row there. I need to file one side off because otherwise it won't fit next to the other connector. Can you even see it? I don't know. Do I have 10 pin connectors here? Yes. This is 10 pin. Like this long ones, probably from a D1 Mini or something. Do I have pin long? Pin long here. These are 8, this is 10. Okay. This is my connector now. I just need to solder it. We can probably just put it in the center of the breadboard. I don't know how wide the... No, I think the breadboard center is wider than that. But we probably could. Not sure. Okay, let's solder it. Okay, I can basically, maybe I can detach it already. Yeah. Okay, like that. The good thing about doing this flip dot thing right now is that we can repurpose it anytime for the accident counter, or maybe multi-purpose it. It can basically, like, we can flip a switch at some point, and whenever we not use it, or put a magnet on the back side of the multimeter or oscilloscope, when it's on the wall, on the magnets, it acts like an accident counter. Whenever we take it off the wall, it acts like an oscilloscope or whatever. How about that? Okay, so this is the first connector part. This is for the rows. Ow, hot. Accident counter. And we need to I need to file off this side because the next one will sit right next to it, so it fits. I think this will be like, okay, I will get this ready. Maybe I can even use, does it have enough? No. It barely doesn't have enough rows. I have so many of these, I can basically just take any one here. That's that. Yeah. How many rows? Wait, what? I broke it. No! I need all the rows. Oh, wait, no. That's stupid. Okay, I take this one. I must admit, I'm not the brightest here. Brightest person in the room. And I'm even alone here. The new video is working well. So we got like, I think it was last time I checked was 25k views. And this is all thanks to you guys and gals. And I need a gender neutral. So you helped me very much with the impedance matching of the VGA stuff, and now it really turned out to be a popular project. I hated to edit this video. It was really like pain in the ass. Why is that like really hard to break? It seems to be a different material. Hate it already. Okay, we need like file of that, and we need until V, I think. Yes, so we V. I will do a break and read the chat soon. So please talk to me. Okay, I think. Yeah, this will fit. I will just file off the edges first. The tripod is annoying today. Oops. Or I will file while I'm talking to you. Oh, Eurocard connector. Okay, when I'm doing like a final design, that we don't need to finish today, I will check for the connector. Okay, let me scroll back. Hello, I have same video projected in use. Something has gone wrong with the power supply and the stage that powers the LED lamp does not work. If something similar happens to you at any time of any... Yeah, I wanted to maybe open one up and check if we can change the cooling of the projector, because there are 6 of those at once, end up being quite noisy, and I want a silent lab here, especially when I'm streaming and such. So I might open one up and try to change it to like add a huge passive cooling thingy, or a huge fan that's not very noisy but can dissipate a lot of heat, or heat pipes or something like that. Okay, this is the narrow side. I hate it already. Doesn't look good at all here. Okay, I need to file off this one side here. Make a Wi-Fi enabled screen that can be used with different projects. Yeah, but we can basically make it simple like that. We need a clickbaity title then. So flip.oscilloscope sounds much more impressive than much more impressive than Wi-Fi enabled flip dot thingy that can be used for anything. We can pump out the project videos that are using flip dots, and I will turn from the LED, ping pong LED guy to the flip dot matrix guy that only owns one flip dot matrix. Try using the back of the knife for the PCBs, works better. What? Really? Find one on a live stream or make it. Okay, it's almost ready. The two connectors need to fit next to each other. So we got first part. Now we need the second part. Okay, I won't cut this one, I think, because I'm annoyed already. So I need the long ones. Pin header female. I will just take that one here. Or we can use the long-legged ones, but multiple ones here. That might work. Want to use some cheapos maybe? You can see. Ah! It's too narrow! What? Why? How is that too narrow here? Don't they fit next to each other? Oh, no, they don't. Ah. But I need... Okay, how many... Okay, that doesn't work like that. Can we use like 2 of those? So 4. No, that's not enough. Okay, I will use one long one here. And I need to shave off a little bit of this here. I will take a different file for that, or sandpaper. Okay. Okay, we have a little bit more space now. I need to file off this one as well. I hope they don't short. You shouldn't. Okay, yeah, that's good enough. And I need to cut it here. Okay, one side. This will be too short, but we don't need that because we have like, we need like only the last ones here. Okay, the last three are not connected. So we need only like a 3-legged one, and we have one here. That's a nice one. Okay. Like that. No. Did we screw up again? There's... Oh. We did. Okay. This is painful to watch, isn't it? The back of the knife. Oh, I don't have a back. The knife is already so short. Flip dots are fun, but also hell of expensive, yeah. Okay. New luck. New try, new luck. I think that the other one might be a little bit too wide still, but I will shave off the last bits here. Okay, this should work. Oops, solder bridge. Okay. So anyone checked how to set up the breadboard for the flip dots. Are the shift registers optional? If we just use a bunch of pins? Ah, 2 hours elapsed. Oh no! Oh, the filings. Oh, I'm completely dirty now from the filings here. I will wash my hands quickly, otherwise I will touch the bread and so on. Okay, I take a break for now. We have 2 connectors, but I need to add some jumper wires, or where are my jumper wires here? Breadboard. We can prototype it on a breadboard later. The best ones would be probably... Oh! I can use some like these. I have like a bag of stiff wires for breadboarding. I could use those. These are only female. I have a bunch of female thingies, but none actual. No, that's not true. There must be. These are male only. Where are the male to female wires? Can find. Okay, let's not waste any time. Brian Luck. Flexi friends. Oh, you are funny. No, I need some wires here. Man, it's something like that, but I need males on one side, or I cut up my male ended wires here, but these are all separated. I rather take a ribbon cable. Da 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 da. Da 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 da. There must be an angel playing with my heart, yeah. I can't find the female to male wires. Okay, whatever. Making few headers, 2 hours. I have no space here whatsoever. You know what? Screw it. I will crimp some. We will do our wires ourselves here. And we can make them long. We'll crimp a ton of wires now. I don't care anymore. Instead of looking for wires all the time. The breadboarding stuff will be easy then. We make the rows blue. What should be the right length? Let's take something like that. We only need 16. Oops. Aye. We can start like with a few, solder in a few, and then check what we need to do there. It's entangled. Just get it out. We just need to flip a dot with an ESP somehow. Okay, that's 8. We got half the wires. We need 16. That will be like the rest of this. We might need only like 2 or whatever. What do we need? No. We have we need like 10 wires maybe. No, 16, 17. Five, 3 more. I got 8 already. Yes, okay. So we have 16 blue wires, similar length. Oh, this is one more. Okay, whatever. Now we need one black one for those 4. Similar length. Okay, so these are the rows. Now we need 25 columns. Let's make it green then. Let's start with 1 first. We make 1. Connect this here. Now we will probe everything. This is like Oh wow. How do we probe this? I need more space here. Ah, okay. We need the first row. Oops, that's mega ohms, nope. That one. Okay, I will solder on this one first. I already forgot which one's the second one. Yeah. Okay. Add some solder here. Whoops. Let's remove this long wires, long things here. We don't need that long. Yeah, let's short everything in my lab. Letting bounce around here. Ah, my good pliers are in the car. Fuck. One at a time was the trick, wasn't it? Substantial amount of solder. Okay. Oh no, solder bridge. Brian, where is the flexi friend? I got the solder bridge here. This is too long. I should have taken silicone wire. This is basically melting the insulation away. Okay. One wire done. I will just tin the end of the wire. We can use that with the breadboard for the beginning. We don't need really to crimp it right now. Crimping takes too long. Okay. That should be enough. First one, I should have used a different color for the alternative pin, so for the reverse. Wait, what? How are these shorted? Oh, is there a short in between? I can see this. Oh, wait. Ah, this is the black one. Oh man, you're probably shouting at me. It should be the black one, not the... I was wrong right now. We need to add the black one. These are like the 4 pins that are connected together. This is the... There goes some extra current. We need to get this like really... Usually we would need a thicker wire here in between. I will make it like this and use maybe a longer end here. Okay, this is black one. Now we need to find the other blue one. So resetting is only like 1 pin. This is reset. And the blue one, now we need to find this. Okay, that was easy. It's the first one. Okay. And now we need to find this here, I think. Oh, that's easy. That's the first one. Okay, we take the green. It's really dull, the stream, isn't it? But it's less dull than coding. Coding will be more like a drag. Dreadful coding. Okay, this is the green one, the first. Okay, let me check something. To be sure that we got this as a reset everywhere here. Yeah. Okay. Okay, great. We have some metallic stuff remains here. Let's remove that and let's try to flip a dot, I would say. Flip the first one. What's the dirt here everywhere? Okay. So the green one, yeah, these are molten. Nope. Let me change the voltage. Okay, 20 milliamps, 5 volts. I don't know which one where. Okay, never do the blue and the green this way around. Doesn't do much. What? Doesn't work. Maybe upright. Needs less power. How does this work? Oops, not blue and... Okay, how do I power this to flip the dot with this small IC in place? Okay, let's remove the connectors. Doesn't flip. Whoops. The first one won't flip. Move forward. Okay. I can hear the first... Oh, now it works. Okay, that works. But how do I use it with the connector though? Oh shit. Oh no. I burnt with my soldering iron, I burnt the cable here a little bit. The power cable from the power supply. That's not good. Ah, how do I turn this off? I don't know how to turn off my soldering iron. Okay, I need to inform myself what I'm actually doing here. Days without accident 0. I can basically set the counter to 0 all the time. I still advocating for a proper pinout. Okay, I have a proper pinout. I have a proper pinout. What do you need? I have like let me check how they actually look in the video. Okay, this is share the screen. Pew. Okay, we got row low and row high. And column is, I'm doing today, it's on the screen, building phase flip dot oscilloscope. So we got row, low and high now, and column. How do we attach it? Let me listen to what he says.
But I've got a schematic diagram here, and as far as I know, this is how all flip-dot panels are wired up. If you just had a matrix with a column line going to every coil and a single row line going to every coil and didn't have these extra diodes in here, what would happen is if you try to energize just one by, say, putting a positive voltage over here and a negative voltage over on the row, you'd certainly energize that coil, but what happens is there would also be a path for that current to flow through pretty much every other coil as well. And so that just wouldn't work out at all. If you want to be able to individually address the coils, and of course we do, you have to be able to steer the current just to one coil at a time. So that's what the diodes do. So on this board, if I want to flip a dot from black to yellow, I need to put positive over here on the row high line and negative up here on the appropriate column line.
Okay, negative. Oh, echo. Oh. Okay, I need to, okay. You can still hear me. Ah, okay, they have a proper pinout. You do not have a proper, did you measure what's low and what's high? Oh, okay. I should maybe use different colors for low and high. Okay, maybe that would be a better idea. So, how do I measure low and high? I can measure it with, when I apply there is the column. This is the column. Oh. Let me turn off the screen capture. This is the column. Okay. So we need to apply, let's apply high there. And that should measure 5 volts on the low side, shouldn't it? So we should measure low. Okay, let's measure it. Okay, I will measure. .7 volts, and here is 5 volts. 3 volts DC, what? No, 5 volts and 5 volts. Nah, I don't see a difference here. 4 volts, 4.1. What? Okay. You have a diode drop between low and call. 2 diode drops between. Yeah, okay, we know what row. Okay, we have a different thing here because, let me show it. This here, we have only either one high or one low. And I think this display only, you can't address like individual pixels, because we have one, I think it is one high or one low. So you need to clear the complete display and then set the pixels again. Hey Matu. Yes, I am German. Diode measurement, but what do I measure there? How do I measure it? Ouch! Okay, diode. We learn how to work here. Diode measurement. Okay, column. And this is basically, this could be high. There's nothing. And this could be low. 0.5 volts. We got from column to, we got 0.5, and the other one is 0 volts. So this is low. The black one is low. Am I right? Okay, so black one is low, and we have only one low. Every other blue is high. So we have one low, which is basically for every pixel. Yeah. So we turn on the pixel by setting column low and row high. We are setting the pixel. Or let's say we can set, I think, like a complete row at a time, can't we? And then if we want to reset, we simply switch around. We set, oh wait, no. Oh, I'm confused. I will check now. Where's our power? So I said we need this too low. This should turn on the pixel, but oh, it's turned on. A different one is also turned on. And then reset it by setting this high and this low. There is nothing happening here. No. Let me increase the voltage a little bit to 12. So we need this and this to invert it. Yeah. That's what happened. Okay, 12 volts worked here. And now we need to flip it. So we need to set this high and this low. Yeah. Okay, so 12 volt is working and everything is figured out. Okay, ignore that pixel here. We need to fix that soon. But we are looking at the upright pixel there. We turn this off right now by using high on green and low on black, and now high on blue and low on green. Ta-da! Okay. Now we need the driver. Oh no, you can see, you missed everything. Oh, sorry. Okay, I show you again. So this is I might even record it right now. Oh yeah, I'm recording. So what we got is now we want to turn it off. So I set green to high and black to low. It's turned off. And if I set blue to high and green to low, we turn it on. Chick! This is working. I had to increase the voltage to 12 volts. I don't think it will work with 5 volts somehow. We get the voltage drop and it's really nasty. I don't think we can, at least at 20 milliamps, it wouldn't work. Okay, let me try to turn it off again. But basically, since we have a reset, like resetting whole row at once is nasty for the current. We can't use it on the microcontroller directly, so we need at least some some kind of driver there. What do I wanted to do? I wanted to set green high and black low. No. 20 milliamps doesn't work. Let me check if I can. $200 milliamps. No, this doesn't work. Okay, 5 volts won't work. Let me try 6 volts then. No. 7 volts. Nope. Okay, 12 volts. Yeah, that works. Okay, we need to work with 12 volts here. A complete column. Yeah, column at once. Sorry. My mistake. Okay, how do we use the driver now? The goal isn't finished yet. We need to flip the dot from a microcontroller. So we need to use the driver now. Okay, let me turn off the power supply before something melts here. Whew. Ah, that's silence. Nice. Oh, what's with our fondue here? Goal isn't done. We need to change it from a microcontroller. So we need to use this driver here. How is it working, this driver? Magic smoke. You need a 595, which is flip dot is actually flip a dot from MCU. Okay, 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 okay. Let's make it. Let's make it. Let's remove this and I need a check mark here. Box. I need a box. Oh, we have a checkmark box and a box. Okay, let's do it like that. That might be even for the oscilloscope, that might be even enough. Okay, let's do it like, keep it like that. D will drive the output high and drive it low. We have a single, okay, so what's happening here? Let me check again. So we have one low here, which needs to be turned off whenever we set the high to high, because otherwise, so okay, here, the low needs to be turned off. We have one low. Let me draw it. Okay. We have a slightly different design here. Okay. We have a column, then we have the coil, then we have the diodes, like that. And then we have another diode. Like that. And this here is all connected through all rows. It's all the same. There's only one there. And this one is for all the coils. Each column, there's an individual one. So we have one individual one here and a huge one. Like this is massive. There's only one here. So this is column. Then we have row high, and then we have all row, low. Okay. So whenever we want to activate a pixel, we have to disconnect all row low here. This needs to be disconnected. We can even use one transistor there. One transistor or even a relay. Good old MS Paint. Okay, we need only to, since this is okay, can we use an N-channel MOSFET here? Here, like here, an NMOS. Can we use it? Because we have a diode which will do that, but it doesn't matter. This is always, we need a gate. Oh, we might need to like drive the gate really high. The 595s are the shift registers with a transistor on the output, open drain. What does that mean? This transistor on the output. Okay, this shift registers. Okay, I know that we need only one transistor here. This is only one for the complete panel. So we don't need an IC there. Or if we have a spare NPN plus PNP pairs on the column side. Yes, because, okay, we need this to drive this negative and positive. And we need to drive this positive or disconnected. Oh, this needs also to be disconnected. Let's make it like that. So let's talk logic here. So we need here, this is probably what you mean like open whatever, a tri-state. NMOS will work fine, but if I basically adjust controlled NMOS FETs. Yeah, if we have one spare, we can take one of those, one channel of those 595s. Okay, that might be a good idea because we don't need to like do some kind of pull up or something. So this 595 this here, one channel, and here also 595. I don't know how, and this shift, it's magic. Okay, let's take a look what we need to do. Drawing with the mouse is terrible. Okay, let's take a look what we have here. I will turn the Fondue off. Power supply pin. Oh, that's like a buffer. So this is what we do, like connect this side to the microcontroller and this side. But we have a diode here, ground. Does it work like that? Low or high Z. Here is, let's zoom in. This is the output. So what we get is if we have high here, nothing happens. If we have ground here, nothing happens. ground. No high here. No, there's nothing. This internal protection diode does nothing. So look like high current 3-state outputs. Yeah, I figured that out. It says it can do inductive loads. Test circuit. Leak. Can someone explain open collector to me? DMOS transistor source type DMOS. This is the first time I see DMOS anyway. Which I should we simply set up anything and test if we can make it work somehow? Simply just breadboard it. 595s. They are open drain, can pull up VCC only. Open collector is that it's able to source the power externally and it doesn't need to flow fully through the chip, basically thus being able to handle larger current generally. Okay. Open drain always gets confused. Okay. Oh. So it could be what you said, but it could be different. Oops, I bent a leg already. Breaking stuff here. Open collector is a high side switch connecting the load between V supply and switch ground. Okay, so yes, here, that's what we need to connect to, I don't know where in our circuit. I think the column, because we need to do high switching there. Should be careful with the legs here. Okay. Okay. I'm preparing the breadboard if you're asking what I'm doing right now. Identifying the ICs and placing them on the breadboard right now. Okay. 3 rows. Open collector means that the collector of the transistor is the output. Open collector switches the output VCC or its high impedance. Okay. 6, 7. No, wait. This. Which one is it? That's the wrong one. What's this? This is not what I wanted. TBD. This is wrong. This is wrong. I didn't want this. Wait a second. 595. And this is oh, yeah, okay. 595. And this is 6. Did I have the right data sheet here? Huh? Oh yeah, that's drain. Oh, it's a serial. Oh, no. Still no pink LED. We will place a pink LED, but I'm tired already, and it's only 10. Look at page 11. Shift register. What's the situation? We have a breadboard, and now we are guessing which side to connect where. Okay, let's take a look at our circuit diagram. This needs to be either high or disconnected. This needs to be high or disconnected. So actually these are the same, and this needs to be high, low. Does it need to be disconnected? No, never. Wait a second. Is that even true? No, it isn't. What I'm talking about, this never needs to be floating here. Oh, it needs, because we need to select a column. Oh. We need to select a column. Look on my Discord. 3 hours elapsed. Okay, I will look on the Discord. But I'm afraid to turn on Discord. It will pop up on our main screen and share everything. Ah, thank you. Thank you for sharing my complete life. Okay, where did you 1 day challenge? No, where did you share it? Where did you share anything with me? A row low needs to be, wait a second. Why needs row low to be disconnected? Because we need to set it, to be able to reset, we need to invert the coil. Or do we basically discharge it somehow? Entrance, who posts in entrance? Entrance is only the entrance, nobody listens there. This is how it works. Okay, Adam shared. I can maybe share a part of this here. No. Buffer both sides. Yeah, what is R low then? We need to connect something here. It needs to be either really wouldn't let you post what? You can always message me. I'm not sure why it wouldn't let you post anywhere. That's a little bit strange. Light mode, I don't understand. Second image. Hello. Dave Darko. Exploiting my live stream right now. This is the second warning, Dave. Nets as pins. Discord is weird, yes. Okay. Okay. I need, okay, let's do a vote. Let's do a vote. I will make a poll here. Okay. What happens next? And then I will, how do I change? Oh yeah, I can change this. What happens next? Looney connects 595 to call. Looney connects 595 to row high. Looney connects 595 to row low. Vote is going on. No regrets. The vote is on. Mini desktop robotic vacuum. Aaron. Okay. No, not row low. That's the simplest one. Only B is wrong. Okay. I hate that we need to use a shift register. I don't like it. Because it's more complicated to drive the circuit. Or we can basically not test it easily. Okay, I think people are just voting such that it ends like 50-50 and we are not sure what to do next. I will end it now and we see the results. Where are the results? Can I see the results somewhere? Ta-da! Yay! 595 took. This is the best community project ever. Okay, so second option is, but why is it row low? Oh yeah, we need to have what? Magic smoke next. Hello to Romania. Don't you just send it a bit pattern? Yeah, I hope so. I forgot which way the 595 went. Yeah, I still didn't get it. Okay. We can basically, I don't know if we can break anything there. We can try to drive. We need like 5 volts here. Oh, maybe I would. Let me take an Arduino fake nano. Here. I will switch to the camera again. 595 to R low. Drives low or it's high impedance. So fine on call or row low. Okay. Look at the data sheet figure 12. Figure 12. What does it say? It's ground. It's either low. Oh yeah, I got it. Okay, so it's just a MOSFET. Why don't you just say it's an array of MOSFETs here? Oh man, is this serial? No. I thought this is a parallel chip. Oh no, oh, it's a serial one. Okay, it's a shift register. Okay. Okay, great. So easy. It's either, so if we look close, these are like N-channel MOSFETs. So it's either connected. This is the gate. It does something neat. And then we have ground. So it's either ground or high impedance. Yes. So ground or high impedance. Let's put it on our data here. 5, 9, 5 is, no, minus. No. Is either minus or high impedance. This is what the 595 does. And then we have the other one, which is the 62783. 6, 2, 7, 8, 3, A, PG. By the way, this is a joke. It just needs to look jonky. Jonky is, by the way, a new word that I invented. It's like janky and honky at the same time. Jonky. So let's take a look what this says. 783 is like page 2. Output and VCC. So we have always, if there is an inverted, it will, okay. So we have an, oh wow, what is that? VCC, this seems like it's not, it's inactive. What is it doing? Clamp diode. It's clamping output. Oh, okay, so this is like the driving this PMOS. What is it? P-channel MOSFET. Sync the source. Paintbrush schematic needs pushing to the repo for future reference. It's epic bitluni stretch. Yonky is a okay, I don't understand. What does it do? It does either high or floating. You need the H bridge on all coils. Yeah, high or high. Okay, that's perfect. Okay, let's see on our schematic. Okay, so what we can do here is we can do high or high impedance. So this is what we can do here. Now we need, so what we need is, we need to select a coil. So either we need to connect to a column, we need to connect both. Do I see it right? We need both at a column, and we need one here and one here. At least two devices must have the same data at all times. Oh, I'd panic nonetheless. Yeah, because if we like, let's add, if we have like this 5, 9, 5 and was 7, 3, 8, 3 here at the same time here connected to column call, then we need to have one of those always like high impedance, otherwise we have a short. If it's like that. Half H bridge. Oh no. Oh, people give me a break. Oh. So we need some switching, like turning off first and then etch a sketch. What? Yeah. Is this what you meant on Discord in the... Ah! Look at this. Dave. So this is what you meant by column here. And then we have, this is what you drew here. And then we need, oh, this is wrong. This is wrong. We need the same on both sides here. Don't we? No, we don't. Yes, we do. Yes, we need the same on both sides. Am I right, Adam? Because what we figured, we need like plus or high impedance here or plus or high impedance here. No, we not. Oh, wait. No, you're right. Okay, we turn it off when this is minus and this is plus. But we turn it off when this is minus. This is wrong. This needs to go minus or high impedance. So this needs to be minus or 595 and 595. This is right. Yes. Okay, so we need the coil here. It looks like pubic hair. The coil, then we have the column here. I'm not even sure if we have enough ICs then. And we need like a 595 here. And this 783. And we need, yeah, and we need basically 595 here. And 783. 783. Okay, this is like, oh, this is like super tedious to set up. And this is the low. Okay, this is only like one. There is only one big thing. This is like the main. This and this. These are the row high and column high. Column high. And this is column low. And we have 16 columns. column low. Yeah, that's the right thing here. That's exactly what you drew. Adam is the stream master for today. Column low 595. Yeah, that's basically it. That's basically it. Okay, now I understand what you meant. And this is like a basically a main, but also this thing needs to be turned off for sure. Thankfully, these are not serial, but these are unfortunately serial devices. So we'll remove that again. So at least the high things we can control precisely before we like do. Still there, I see. Yes. MS Paint. Okay. Shall we try to drive? We can use Arduino Nano, fake Nano, to test it first. And then, or should we just try ESP32 right away? Right away. Right away. Okay, 595 can do 20 milliamps. I hope it drops in voltage then and doesn't like burn. Driver circuit. Okay. I will use the ESP right away. No time to lose today. ESP8266? No, we need the pins, don't we? Yeah. So let's check the functionality here. This is the seven. Okay, we need a clock. We need power, we need clock, we need ground. I will move the camera over here and we will build this thing here. You need to trust me. I will build it right now. Okay, so let's do the easy part first. Okay, you are discussing stuff there. I will take this here as 12 volts. This is theoretical 12 volts. I will just use 5 volts for now, since we got 5 volts from USB. Okay, let me grab a micro USB. I think this one is broken, yeah. I need a short one. I've broken my cables here. Okay, so microcontroller. I need to read. There is VGA running on that one here from the recording when I was filming for the release at this weekend. So I need to reset it. Let me Arduino, and let's get a clean slate here. 12,000 euros for data recovery. I paid once. It was 2,500 euros for data recovery, and they weren't able to recover anything. That was the death of my former company. We lost the complete database basically. It threw us back by one year of development, but the restart was like with responsive design and so on, so it wasn't that bad actually. But nobody would understand the concept of the company that I started back then, so it wouldn't matter. I didn't ever earn a cent from that. Okay. New sketch. Should I share the screen capture as well? Okay, let's do it. Ah, I hate it. Okay, screen capture. COM3, yes. I store it. Flip dot. Code. Flipped, oops, no. Okay, sketch is stored. Now upload it. Oh, you were lucky, Johnny. What happened to me was the backups, the setup for the backups was on the top priority list point, but some other stuff always intervened with setting up a proper backup. And we had a RAID 1, that's why I was like convinced never ever something would happen to it. And we hosted at Hetzner, that's a German provider. We had like a dedicated server that we rented there, and what happened was that at one point, basically our site wasn't reachable anymore. I tried to dial in with SSH. It wouldn't even start in the recovery system, or the recovery, what is it, like partition or whatever. And I called them, and they said, both drives are dead. Should we scrap them right now and replace with fresh drives? Say, what? It's RAID 1. We rented a RAID from you. Didn't you just swap a broken hard drive? And they said, no, you have to do it yourself. You have to inform us whenever a drive is broken, and we will replace the drive then. So that was all. So the one drive was probably dead for months already. And since I'm not a Linux guy or Unix guy, no, we had Debian 6, I think, at that point. I basically never saw that something's wrong with the system. And one drive was really dead, and when the second drive died, we lost everything. That was the end of of that story. And then we had this extra cost of the recovery, which didn't work, and yeah, that's sad. People, do your backup. I wouldn't ever do a dedicated server now. I only do virtual servers now. Virtual servers with like organized backups, daily backups, and one backup is like weekly, which is stored for a longer time. It's like Strato. It's like super cheap, but it's very effective, and I used it already. I'm so bad with my server. I'm so bad with that. At some point, something was like broken, and I thought, wait a second, I didn't change a thing since yesterday. I basically reset the server, the backup from the day before, and it was all right again. I don't know if it was hacked or whatever. You flipped out one day. At least you didn't have days. Okay, I do the Earth Day flip dot. I just programmed the ESP32. We are already at the code prototyping stage. So we have the 5 volts here. I need 5 volts from here. Where's the 5 volts? 5 volts will be here. This is the third from here. Oh, I will use the square one, I think. The square one is better for this thing. Rambling about like my past failures from the past here. Nobody wants to listen to that. Okay, this is the high side. Then we need the ground here. Like a square ground. Okay, let's do a blue then. Blue ground is above that. A year ago, one of the SSDs in my RAID 6 had died, and I just happened to notice that by mistake. Oh wow. But usually, what I don't understand, usually every system, like professional system, will start like beeping like crazy if one drive is broken. So I don't understand how the people in this like server farm, okay, maybe there is a lot ongoing with like super loud fans and so on, but if there is something beeping, I go there and check it. Draw schematic? No, we don't need schematics here. No schematics. This is a schematic-free zone. We have the schematic. Here is the schematic. This is our schematic. Here, this one here. So we need 595 and 783 at each column, and we need, okay, what we need to set up is like one instance, one pixel. What are we building? Aaron, hello. We are doing a flip dot matrix project today. So I got this thing sent from a viewer, a nice supporter, and we are trying to drive it. He also sent like these ICs here, and this is our schematic, how to set it up. And basically we have it also on Discord. Where's the Discord? Here. Yeah, this is what we want to set up. And this is the 783. This is the 783. And this is the, well, 595, this here. I don't think we have enough of the ICs, but we can make it partially work, I think. You need to monitor the RAID controller. Since it's dedicated server, you have to do it yourself since it's yours to run. If it's a managed server, that's different. Yeah. Yeah, thanks, Adam. That's what they also said, but that didn't help me. Now everything is backed up. I have like my disk station. I have like this cloud station set up for my PC. So the videos that I'm working on, the material, everything is backed up to my file station, and the file station, that will basically beep if something's broken, then I will turn it off immediately and switch the drive. Yeah, double Aaron. Aaron, I will say the English, the British Aaron, I will call Aaron, and the German Aaron, I will call Aaron. Aaron, I watched your video on your hack from this van vent. This was like crazy. You went through so much trouble, like to hack the device, to change the maximum value where it like stops opening. This is so crazy. Oh man, you are the most famous hacker that I'm watching right now on YouTube. It's like, and congratulations to your channel. It's like working really well. You have like 8K already subs, I think. Okay, we want to drive setup 595. We want to check how the 595 is driven. So this is not what I want. 595. Oh, do we want to start with 595? Yes, we want, because this is serial connection. Serial in, serial clock, reset clock, or what is this? Reset, this is not ground. What? Functional block diagram. Okay, the 595 is really hard to drive. To turn off immediately, not the right call. Leave it running and replace the drive spinning. Yeah, that might be a thing, yes. But I would need to order a new drive. I don't have a spare drive of the same type. Okay, let's try to set up this tedious IC here. VCC, ground, not ground. What is not ground? What is not G? What's the not G? Anyone knows what not G is? Serial in VCC. Wait a second. This is the what is this? Okay, so 595 is our source. And RCK to make it show on the outputs. Okay, yeah. So make it so. Oh, okay, that's nice. Okay, but what is not G? What is this not a gangster? Okay, I will do the clock. I will do two will be the data and 4 will be the clock. Two will be the data. This is the data. Yellow is data. This is serial in. This is pin 3. And this is clock. We can chain all the ICs later. Where's the clock? Serial out ground, serial clock 13. That's this one here. What is not G? Is this the not ground or what? It's the high. Oh, I should disconnect it first of all. While I'm working on this, I should disconnect it, really. Okay, this is like the ground. And this is the ground. Maybe should I even do it, or it's like basically the same pin? I just need one. Or even no, this is okay. Not G. Not G is what not G? What is not G? Is there a description what not G is? Oh yeah, here. Output enable. Serial in, serial out. Register clock. Shift register clock. Shift register clear. And it will be like instantaneous. Okay, so we have data, we have for, let's say 5, 2, 3, 4, 5. I need a different color for this. This will be the different color for. This is the not G. Not G is 9. Oh, I'm so slow. Okay. Let me write the sketch. This is not the sketch. This is the Starfield sketch. Okay. So we have serial was 2. SRCK was 4. Was it 4? Then we had not G. Not G is 5. So we are on track here. And then we need what we need. Where's this one here? So a register clock. So this will basically propagate the data from the serial here. And then, okay, so we shift, then we propagate to the D flip-flop here. And this is basically what gets output here. Oh, now I understand everything. Okay. So we basically need clear, if we want to clear it for whatever reason. Why would we clear it like that? Not clear. Clear, invert. So when we send high, we should set this to high, to not clear it. Okay, so serial clear needs to be high all the time. So this needs to be connected to basically a high signal. Or is it floating? Can I let it float? Is it like pulled up by default internally? Does anyone know? No. Yeah, I don't need to clear, but I just need to know if I can leave it floating or not. Clear shift register, clear active, low. It doesn't say that it's pulled up internally. So I will just set it to 5 volts and I know to 3.3 volts. And I need the 3.3 volts here. I'm wondering how does the IC, where is the power? Oh, VCC, there is the power, okay. So it does know from the 3.3 volt operating voltage. This is the second pin. VCC, okay, great. This I hate the serial stuff. I want always like parallel stuff. What is the logic series of the chip? LS or HC? I can't see. What is, I don't know. Typical application, figure 14 pulls it up. Yeah, I just set it high because there's... Is this internal or where is the figure? Figure 14. Yeah, that's what I said. Clear 10k ohms. I just pulled it up. Magic smoke. Okay, now I need to test it. I think we set everything up. We have the not G, serial clock, not G. Oh, we need the propagation here. Const int. The fourth one was register clock, RCK. And that was basically, what was RCK again? Where's my, did I connect it even? Where's RCK? I think I didn't connect it yet. Mm-hmm. 12. I didn't connect it yet. Okay, so this is clock, serial clock. Okay, I will do another white one here. We had 5. The next free one is 16. Yeah. 4, 16. Okay. 16. Okay, let's try if we can make it work actually. So we should see 5 volts on the outputs whenever. Oh, anyone knows how Arduino works? I forgot already. Let's do it like that. We are getting closer, friends. We are getting closer. It's like once we have the driver circuit set up, we need to solder some thingies there and we are good. So here is documentation of the magic smoke. By the way, datasheet says the high level input voltage should be... Oh no, no. VCC isn't 5 volts. I'm running it at 3.3 volts. Is the operating voltage like 5 volt or what? Supply voltage. No! Oh, I hate it. Mm. Well, try it. Try with 3.3 volts. Do you think it will work? Okay, we can basically. I will code first and then attach it and then see what's happening. Pin mode. What's the pin mode? Oh yeah, that's the right white serial, and then we have output. Yes, okay. Oh, let's do it like that, like man. Oh, like coder. Okay, not G. Not G should be not outputting anything. Okay, now let's write void. Write 595. What's the clock? What's the maximum clock? Anyone knows? Let's do long, whatever. Long data bits. Do stuff first and do stuff next. So what? Okay, push bit. I should move that before that. And then void I'm not sure if we even need that. Yeah, no, that's all right. That's what we need. Okay, so we need not G. So digital write, not G. And then not on off. So invert on off. Or let's do like that. If on off 0 1. Oops. Then we should during we shouldn't do anything with enable. We might want it or not want it. So we want to do RCK. So digital write RCK. This is what we want at the end. RCK, we want to push the register. We want to set it high. Then delay for, I don't know, how many, 10 microseconds, 10 milliseconds, 1 millisecond. And then low again. RCK 0. And the same thing happens here. I don't know what's the 1 millisecond should be. Okay. Okay. So we should also take care that we get a square wave here. And digital write serial and then bit. I don't know. Is it like that? Is this all right? Should be all right, huh? Megahertz. Few megahertz shouldn't be a problem. Then we should maybe delay microseconds then. Delay microseconds and 1. With microseconds, we got 1 microsecond is 1 megahertz. But I think the lowest they can go is like 10 or something. I'm not sure if microseconds 1 does anything. Let's define it here. Const SRCK, or it's CK micros. So we don't have it hard-coded. We could even like delay nanoseconds, I think, but that should work. Data is sampled when rising edge of the clocks. So rising edge, this is right then. We set the bit, then we rise the clock, we wait, we lower the clock, we wait, and we are ready for the next bit. Or we should maybe do it like that. Here, this is more secure. So we have at least like a stable signal, and what happens here, it doesn't really matter. Lowering clock. Okay, so we should have like the serial stuff set up. Let's do init 595 and basically push everything in there. And then we have something like that. Oops. So init 595. Then we have write 595. Oops. Write 595. And let's set it all to, should we set it like to all ones? 8 bits. And we want to write 8 bits. And then we want to enable. Okay, we don't have a pull down here, but basically what we want to do is loop true, false, and delay 1000 milliseconds. I hate this, sorry. Haters gonna hate my style of coding, but I like the... okay, so let's push it and see what happens. Oh, see you, Justin. Push bit. What is the push bit 5? Oh, yeah. What power? What? Oh, yeah, it's not connected. And Brexit? What? What? Power cut out? How does this happen? That basically never happens here. I can't remember in the past 2 years I didn't have one. Okay, so we should see some action. I'm not sure if anything is happening. We should see some action. We could even use a diode to see what's happening there, like an LED mine. Oh, we can use a pink LED to test it. Okay, what is the pinout here? If this works right away, I will eat my head. Thankfully, I don't have a head. Pink LED for the win? Okay, look at this, look at this, look at this. This is our ground. What? Come on. I had it. Ah. Okay, I had it. I had it. We will do it with an LED, with a pink LED. Are these the pink LEDs? I have no clue. I will solder some legs to this fake pink LED. Do we have like a double action wire here? Yeah, let's take this here. Cut it. Where's my wire stripper? I need a stripper. Oh, there, on the floor. Okay, it seems that it works at 3.3 volts. So basically it's over-spec'd here. Ah, this is hard to solder. Did you ever solder 0603 to basically a jumper wire? That's what I'm trying to do right now, just to save some time. But I'm not saving any time at all trying to do this. Man! I might or might not have a connection here. I saw that it just to the end of this wire. But I don't see anything. I will just try to see if we got anything here. Oh wait, I don't have a ground here. I will just use this ground. Let's see if... Oh. Did it work? No. This way around. Oh yeah. This is the pinkish. And now we need to basically connect it to any of our outputs here. Yeah, it's doing something. So the pink LEDs are 3.3 volts. Yeah. Yeah. Yeah, I know, VCC. Let me... Okay, so Okay, one success. Oh, use driver from MCU. Oh, almost there, almost there. And I'm driving it at 3.3 volts. But 50% duty cycle, so it's actually not overheating. Oh, this is getting fun. It's getting cool right now. So next step, charcoal in 20 minutes. First try. This is where everything turns in charcoal. Yeah, it's interesting. It's like the coding part was so fast this time. I seem to be like there is still some steam in my head already. Still yet. Okay, my head is off. But coding is I do it in my sleep, so that was actually quite easy. And we can now. We could try. Oh! No. Okay. We need to be sure. Maybe fine for the flip dots. Open drain may not be that low impedance with only 3. Uh-oh. Check. Yeah. Okay. I like this test wire now. We have like basically a pink LED at the end of two DuPont wires. It's like this octopus LED tester, but only like I call it a plankton tester. Or the firefly tester. Ah, dude. Sure it stays off. Oh, you mean, oh, yeah, we didn't. We just do it like that. Okay, let's send 0 then. It might not work. You're right. Oh no, it's working. It's working fine, I think. We could even like move this here and there. Oops. Like write this false. Yeah, but this doesn't make sense. And then write 0 like that. But then it will quickly blink while we are writing it. So let's do this final test that should basically do the blinking and with some interference that is not visible to the human eye. We should push new data. Oh no, it's not working. Oh. What? Enable false, it's true, right? 0, right? Uh-oh. It's not working. It's not the first try. Uh-oh. Or did I do something wrong here? Right, 0. No, it should show for 1 second here. False, right, true. Huh? Now it works. Okay. It worked for a few seconds. Huh? I'm confused. Working. It stopped at some point. If I toggle RCK, sure, here. Wait, no, here, yes. This is at the end. It might be too quick here in between, so I don't know if we need like a delay after the enable. It might be an issue, but somehow it works sometimes, somehow it doesn't. Is this pink enough for you? Oh yeah! With my hand it looks really pink, even on camera. Woo, pink, woo! Oh yeah! It was basically here disconnected. No. Is it the right pin? No. Here we go. This is not the right pin. This is one right pin. This is one, and this one is okay. Yeah. It wasn't pink. Okay. Now we need the logic. Dudes. It's Wednesday, my dudes. We need the other one, which is parallel. Now the other IC, yeah, that's what we need. And now we need a ton of wires. It's parallel. We will use, what will we use there? Where's the flip dot? Here. One dot is flipped, but we need to. What we are currently doing is to set this up, the drivers, so we connect it to the flip dot, and this is our plan to do it like that. This is our plan. Okay, so we are done with programming the 595, which is serial. Here, this one is done. And this is parallel. This should be easy. And then we need the sequence to set the pixel and delete the pixel. This is what we do after that. And then we need like a drawing function. And then we need to do the multimeter. It's still doable in like 6 hours probably. Most of you will be sleeping, but I'm keen to finish it today. At least like with this ADC with this ADC of the MCU here, which isn't great. You need to stretch and drink 4 hours plus. Okay, stretch. Oh, my back hurts. Okay. Water. A bottle of water. It's Tuesday, isn't it? Okay, I went away for a bit and came back to pink LED. Yeah, that's our testing LED. Okay, using driver. Okay, so rake of recognizable. Oh, it's not working. It stopped working. There is something. We need to check the connection from time to time. Sometimes it stops working. Ah. Okay. Okay. Back to the roots here. Oh, cool. Yeah. This is great. This is easy. Mates, we need a thick cable. I will take this one here. This is my trusty jumper cable because we need some kind of like substantial current to drive the pixels. And we put it and we power it here because this is the high side driver. And then we need some ground. Ground isn't very serious on this one here. It stopped working again. Start working again. Do we do? Okay, whatever. Ground. Sometimes it's confused. Something's confusing. The way we're talking to it, it's confusing. We might need to add like a delay micros after the enable and disable thingy here. We only saw it after that here. Now it starts again. Okay, it's basically sometimes it's. Okay, I think that might be more robust in this case. Okay, oh, now we need a ton of pins here. So I take some yellowish parallel output. Is there a enable? No, isn't. Oh. There is no output enable. Oh. Okay, so. But that's okay, I think. We might not have enough output pins for that one. I hope we have. I'm thinking it should be interesting to put in like an intermediate stage. It stopped again. It's confused. Not sure what's happening here. Sometimes it stopped again. It's not very reliable. I think it really needs the 5 volts at the end. Ah! It started again. Or did it crash? I have no clue. I think that might be really an issue here. Why is there a fondue? Because I need to stay nutritioned. There is always a fondue. My secret is there is always a fondue. Oh, this is wrong one. Come on, okay. Okay, there might be some bugs here. All disconnected. Electrically conducting. Okay. This is columns call. Let's say it's 8 for now. And now we need to find 8 free pins here. Seventeen, 21, 17, 21, 17, 21, 17, 21, 22, 32. What is TDI? 32. This is still an output pin. 32, 25. Oh, this is our audio. That's unfortunate. We might need to change this later. 27. $23 and 19. $3 and 19. Okay, these are the parallel output pins. And now we need to see if we get, yeah, that's like very simple. Setup in, oh yeah, void init. What's the, again, 783, and then this is a parallel thing. This is very easy. For int I. I see I is smaller than, what is it? Call count. Oh, that's like a bad name because we are mixing up the dot matrix and the columns right now. Yeah, okay, let's leave it right now and do it later. Let's make sure it's pulled low, or call, is this call high or call, yeah, call high, I, pin mode. We don't want surprises, so we set it low first and then set it to output. Okay, so this is the init. Now we need void write 783, and there is no buffer, no anything. It's a basic MOSFET. Oh, let's do two write. Let's do long data and this is like different. It works different than the other one. Long or bool or int bit bool index and bool bit. Okay, we can do this. Index and bits. Is this inverted? No, it isn't. Okay. And we also want to write maybe everything. Yeah, let's do it like basically like the init. Where's the init? Like this. Sorry. Yeah. Okay. Now let's do serious business. 4 rows and 4 columns? Not really, because we can do 7 columns. No, wait. We need the low side. Almost, because this one is only once. So we have, yeah. We can select, yeah, that's a problem. We can select 7 columns right now and 4 rows. 4 rows, 7 columns. Because this is only once. We will take 0 as a reset for the 595. The first thing will be the reset. Okay, let's code it like that. I'm scared. Void the flip. Okay, let's make it short. Flip dot reset and then row. No, column. Here, since, okay, what we did right now, I can explain it. We set up the control of the low side and high side drivers to drive the flip dot with 12 volts that they need. We have did a connector earlier with only like wires for 1 dot so far, but we will extend this. Extend it for the ICs that we got and do like flip reset all the things. Reset column. Okay, we might want to test the output of, let's write the output 738 like that, enable true, write 738, and then let's test if it actually works. 0B 00. Let's do it 10101 01. Okay, and flip it here to, oh, that was stupid, like that. Okay, so they should be alternating right now, the bits. Let's write it and see if the magic smoke escapes, since we got the high side now. That might even like, oh wait, this is not the right one. I need the other USB cable. But I need to switch it. Okay, now it turned off again. This is so stupid. Okay. It's sometimes the shift register works, sometimes it drops out. I don't know why. Maybe because of the 3.3 volts. Okay, this is blinking. Now I need to measure, since we have the high side, we can probably measure the 5 volts, I'm not sure. So this is ground. Oh, AC. Nope. I don't see this changing here. Oh, wait. Wait a second. VCC. This is the high side. I'm confused now. What is VCC then? It needs to be like 12 volts then, but how does it recognize the signal? I'm confused. Ah, input voltage on 2 volts. Okay. Okay, yeah, that's working. But why don't we see an output here? Okay, it's maybe we have a okay, let's use our test LED. This, since we have always like this high impedance stuff, let's check if we can measure it like that. We need, oh, that's 5 volts. Okay, let's try 3.3 volts here as the driver input. 3.3 volts, and here we need ground. I think this was ground. No. Different way around. Okay. Okay, it does nothing. So the code doesn't work there. Okay, this is all right. Okay, let's try. There might be somewhere a bug in my code. Write data, call count, call digital write, shift and 1. Oh, we didn't do the init. Yeah, we forgot the init. Okay, yeah, let me revert that. So we have our actual test. Ha! So this actually isn't that bad, isn't that bad? Yeah, okay. High side works as well. Friends, we are on a good way. We are only 5 hours in right now. And we got the drivers. Use driver, but we need to use the driver for from MCU. Okay, we need to change the goals, because so what we did is now pink LED. What we achieved instead is MCU dot. Okay. This is what we want to do next. MCU dot. Okay, then let's add the more goals. Many dots. And then we need like a waveform. Draw analog. Draw wave. These are the goals. Wiring this will be a mess. No, it won't. Everything is perfectly fine. I tell you, we will leave it on the breadboard. This is perfectly fine. We have a pink LED. This is the most important thing. Okay, we might want to switch the LED. Oh, look at this! We might want to switch one LED on this MCU by a pink one at the end. Roland, gute Nacht. For everyone, you can who needs to go to bed right now, you can basically check the replay tomorrow, and I might do like a conclusion on the main channel of this project. Waiting for sparks. No magic smokes today. 5 additional breadboards? Why? Why do we need 5 additional breadboards? We only have this ICs. We don't have enough ICs to drive everything, I think. These are the only ICs that I got. I don't have more than that. So basically, this is everything I have. You are already in bed? Oh. Okay. Okay, let's be quick now. We need to flip a dot. So we need the sequence. We need everything to be like turned off. Let's write down the sequence. Sequence. Where's our schematics here? This is our schematic. A sequence is always to turn off the high side and the low sides. Everything needs to be turned off and then reconfigure. That's not the most efficient way, but it's the safest way. Then second, whoops, sequence. Let's say set dot set column low, third, set row high. Then clear column, clear column is set all high Z, high. Then second, set column high, and then third, set, oh, this is like momentary. Okay, let's do it like this. Set all 0, set call low 1, no, 1, set row high 1, and then set for set row. We did it like that, didn't we? 0, since this is momentary. We need to be sure there. Okay, let's do it again here. Set column, set row low 1, set column high 1, and set column high 0. This is the sequence of Luni's head. No, I don't touch it. At the end we have some kind of like mains ground loop or whatever. That's a scam. It looks pink. It looks pink when it's reflecting, like here, almost pinkish. My skin looks pinkish. Yeah, that's a scam. It's not the real pink. Pseudo language. This new pseudo language. No, this is like really clear column. Okay, so this is what we need to do. Dudes. We need to... Oh, yeah, it's quite easy. We can enable false like this. So this will be... Oops. This already disables everything on the 5 blah blah blah. This is also 0. This is the first step. Then second step, whoops, why do we have like 2? Okay. Second step, we need to set the row low. This will be always row low is 595. This will be always 0, okay? We take 0 as the low because we have only one reset pin. That's why we take 0. So we use write 5 data bits. Okay. 1 and bits is, let's do the row count. Row count is 8 currently. Let's do it like that, since we, oh wait, oh yeah, leave it like that. No, that's not right. That's not right. Column count high, that's also not right. Oh, we need to change the name here because this doesn't like match with the columns at all. Okay, whatever. Let's do like low count is 8 and high count. This makes more sense. This makes more sense. This is the high count. Yeah. It's a little bit different definition here. High count. We could even maybe do a default like high count, no, low count, like that. That should be equal to, so we have a similar definition here. If that works, I don't know. It's static, const, static, no, const should work. Yeah, it will be a flip top. Trust me, we are on a good way. We did like this pseudocode and now we are driving high count, high count 1. That should be perfectly fine. First bit is reset is all row low. Then we need the column, which is here, reset column. This is now we need a logical mapping of this one here. So we have always like 2 bits for each. That's like super easy. Divided by 2 for each. Oh no, wait, that's the rows and that's the columns. Now we need to decide what to do. Let's do the columns first. Let's do terrible. Okay, we will extend it. We will extend it quite soon, okay? Let's do for I hate it. Square is always the best. We need to maximize the area. Square is the best. So we split it 4 and 4, and we will not use like 3 of those. Is there a better solution? Like if we use 6 by 2, four by 4 is the best we can do. Yeah, let's do 4 by 4 and waste some bits. Okay, so let's do columns here. We need, oh wait, what I'm doing here? Call and row count, and now we have 4 by 4, and now we can calculate the actual bit of the column here. Init. Now So the column, let's take the first bits, that's one shifted by the column. This is the easiest one. And we will do the column first, and then after the columns comes the rows. So we have the first 4 bits will be columns, and then we delay, like we need like const int, and this is like the reset delay. That should be longer than the other. $100 millis, 10 milliseconds, 20, 50 milliseconds, 50 milliseconds. That will be really slow, but it might work. And now we need to deactivate it. We don't need to have a short. Zero. That's all what we got. This is resetting the column. Now we need to set a pixel, set a dot. Let's do void fd dot xy there is no way we need if we need a buffer for everything if we want to redraw or something, like if we want to set a color on off, then we need to redraw the complete column each time. Sorry about the mic. Okay. This is our first thing to do, set all 0. Then we need to set column low. Column low is our 595, not 555 timer. Set column low. This is like 1 shifted by 1 plus, and that's the column. Set column. This is like X. And then set row high, which is this 1 column plus, no, y plus column count. Now we need to wire it correctly, otherwise we get a huge mess. Sorry. It's a little bit too much scrolling here. We have the columns first. Okay, not reset delay, we have the set delay and set row, high is, oh yeah. Yeah, we basically clear that. Like 0. That is all, I think. To reset the row, you need to write 5. To reset the row, we don't reset the row. There is no reset row. What? There. The first column, high and low. Okay, my plan is this is not high. Johnny, thank you for the super chats. Skip the script and my Rickroll device is also SDK roots. Skill this. Okay, I will put the pink LED in focus to calm you a little bit. This is also not the column high. This is like, I call it the high pin. This is maybe confusing because we have the first one is the reset row. Because basically, okay, we could do columns there and put it at the end. You dedicated lower 4 bits to the column drivers. No, wait a second, there is a difference. Not the high side and the low side are different, because the high side, the first bit is dedicated to the, maybe it's a bad definition, okay, I admit, but we have only one reset pin for the low side of the rows. So I wanted to put it first, and everything after that is only columns. But we can change it because we have the column. Oh, thank you. Won't let me pick SAKs so you don't have to do it in Canadian dollars. You are in Canada? I thought you were in Australia. Canadian dollars. I'm confused now. Thank you very much for the 5 Canadian dollars. I put it to the true pink LED font. The reset is not part of the high side pins. The reset is low, row low. Yeah, but there is only one reset. Oh, okay. Fruchtzwerg. We have this year, let me mark it here, this one. There is only one. There is only one. And this goes 5. Oh, you are right. This is low. Oh, sorry. Okay. Oh no, 595. No, but there's only one. 5951. Let me check if I messed up. Let's put it at the end. High pins. I need to change this since I changed the definition. Call high. This is like high pins. Call high and high pins. This will completely break apart. Pink LED. I know that all row. Okay. Let's go through it again. Okay, so reset. This is high column. And now we will, okay, I will add now, since I changed the definition now, we will do column count since the first, this is what I didn't maybe explain well enough. I will do this now, but we didn't have the definition before. I just defined the first one is row low for every row. But now it's like better defined. Let's say the row low pin bit comes last. So we have all column counts first and then last. Now we can use this like that. So it's not confusing anymore. And Y is column count, and that should be all right. Oh, we have also enable false. This is not right here. Enable true here. This was missing. This is also here missing. Should we disable everything at the end? We should. Since it's stable, we should maybe disable everything. Huh. It might be important to set it to disable everything there as well. I think that's a great idea to do it like that. Do you think we need like a delay here to let it like, yeah, let's make it a reset delay, then we have a set delay. Make it safe. Okay, set delay, let's leave it like that, and then we have like let's do it like change delay. So we have like 2 milliseconds here. Like turn everything off so we don't have a short. I will do like a change delay here. Reset delay, change delay. It will be slow, but it will be safe, I think. Change delay. Change delay. Set delay. I think we are finished. See you, doctor. Okay, we have everything disabled. Let's say disable again. Okay, let's do it like that. Disable again. And disable again. Okay. Whew. Let's compile it. If it's still compiling, it might be call high. Yeah, that's the high pins. That's changed. I hope that works. Yeah, it works. Okay, great. Nothing changed. Nothing changed. Still blinking. Everything is right. Now, now we should do as follow. fd reset fd reset 0. If this works, I will eat my head. fd dot 0 0. Okay. We can disconnect this one here. Now we really need to be careful. I will edit later, but we need to be careful with the wiring now, since we need the 12 volts here to make it work again. Okay, nothing is melting right now, so there is at least no short so far. Nothing is melting. Okay, great. But nothing is connected either, so it shouldn't be. So this is this row here. We have a common ground. But this here will be disconnected because this will be 12 volts in future. And also this one here isn't, this should be also 12 volts. So this is 5 volts now. This will be disconnected. I will remove it like that. And there is only one thing to do, is to get 12 volts, like wire this up. Oh no! I'm afraid. I'm scared. I'm scared, not afraid. Okay. In our wiring, there is still something missing. Raspberry Pi hat in advance. Okay. In our wiring, there is one thing missing. The connection between, the connection here between. We have the columns first, so we need to connect the 4 first, and this will show if we get a short or not. This thing will release the smoke if we did something wrong. Or should we limit it? Should we limit the current? Yes, we should. I will use a resistor there. We have a resistor here. What kind of a resistor is that? We can use like measure the current in between. Okay. So we need the pins. Where is the pin out? Okay, that one. Drain 0, 1, 1, 2, 3. Okay, so this is 1, 2, 3, 4. This is the worst. This shows if our sequence is correct or not. Okay, maybe we don't have enough white ones. White ones. Let's take this. The breadboard is already a mess. Ah, come on. Okay, I will take this gray or green ones. I don't know what color it is. I need long ones. Give me long ones. This isn't even the right type. Okay, we have 4. I will remove the 5 volts here. Or, okay, we can test it with 5 volts though. And this will be connected to the first 4 over here. Okay. Okay, let's do this 5 volts again. Oh. I will see. Let's see. A second. It doesn't get hot. That's a good sign. Formidable fuses except for plastic smoke. Yeah, okay, so actually it seems to not explode. No magic smoke, no short so far. Let's see if that also works with 12 volts. Now we need to move this thing over to my power supply, otherwise we can't connect it properly. So, and then we have like 4 times 4. Oh, that might be not long enough. Is this cable long enough? Ah. Oh, I might have a cable extension here somewhere. Nope. Oh, but I found something cool. This is my pointy tip of the probe. I was using always like this, the other one. Okay, I need really to move it over. I don't have a long cable to my power supply. Oh, this one is even broken. Shoot. Ah. No. I need a good power cable for this. Something that's long enough. That might work. Speaker cables here. Is this long enough? That might be barely long enough here. Can I reach it? Oh, barely here. It's already like super. Okay, but this is like super junky here. I need to clean this up a little bit. Ah. Okay, let's see if I can even pry this in somehow. This breadboard here. Ah, no. I need something like a pin or something. Yeah. Okay. Okay. Oh no, that one fell off. I'll be soon back. Sorry. I just need to prepare a clean power connection, otherwise we'll have a bad time. Okay. We should have 12 volts. I'm scared. Magic smoke. I just used pins from a pin header and soldered it on. It's like a fuse. It will, if it gets hot, it will desolder itself. Okay, you know what? I will put here, I will connect these rows here, so I have a little bit. Why is it so short? Ah. Oh, it might work. It's too close to each other. Okay. Okay. No shorts so far. Ah! I need a tool. Tools. There. Okay, this won't slide away anymore. We can measure now. We should have like high and low, minus, plus, whatever. I don't know. Like maybe for, okay, it's turning off all the time, but I have no clue what we are doing here. Like setting, resetting. So actually that and watts and voltage and let's say millivolts. It does something, but I don't know what. Okay. Yeah, I know. I don't mix those things. We have that one. We have the grounds connected, I think. Do we have the grounds connected? Yes. Oh. Something slid out here. Uh-oh. Should be careful with that one as well. We'll clamp it like that so it won't move away. Everything should be secured. You know what? We only find out if we try. And now we need to basically do the right thing. What was the high and what was the low side? Anyone still know? Black was the low side. Black was low side, which is, let me check to be sure. Paints 595. So it's the fourth one, which is, I need to pick the right pin. Drain 4 is 14. It's right next to the clocks. Then we have blue. What was blue again? Blue was the column which goes here. No, wait. Was it the column? Uh-oh. No, it wasn't. Green is the column. I just shorted something already. And green is the row. Oops. A row high, which is here. Nothing happens. Is the output on? Yes, output is on. Ah, this is not stiff enough. Shoot. No, this isn't stiff enough. I need to solder something on here. Ah, I need to turn this off. Otherwise it will... Ah. Okay, let's see if that works. Okay. Let's turn it on, but I don't see it working already. No. I don't see a current at all here. Black row is 4 of, yes, this is the bit 4. No current, I don't see anything. I should basically check what the IC is doing. I can measure this easily. The other ones are a little bit harder to measure, but I will check if we see anything or... Okay, this is ground. Do I see anything happening here? Something's happening there. Something's happening there, but I'm not sure. To be honest, it's like jumping around. Do we really need to get the oscilloscope? Man, I hope we don't need it today. Ah. Challenge has 6 hours elapsed. Oh. Soon. We are soon finished here. I need to measure stuff now. What is this? This probe. What is this? Crap. Okay, so let's see what we got here. Okay, you can see it. Our roll. No. Horizontal. Where's the roll here? Time modes. Okay, we get short pulses. The fuck? Okay, shall I show you what we are seeing here? So this is happening on the row reset pin. then we have, this is the active on the row side. Oops. Okay. Then we have the active on the pin side. What's the sync side saying? Wait, this is green. Oh. Is this right? Okay, let me check. I will change the delays in the code. Reset delay should be now 200 and set delay should, reset delay is 200, set delay is 100 milliseconds. I will change this. It never goes to VCC. It goes whenever the coil is discharged. No. Wait, what? Connected. Yeah, it's connected. Everything is connected. We have connected it to the actual flip dot. Or we didn't connect it properly. It might be also the case. Okay, I changed the timings right now. Okay, I will make this horizontal. So this is the width of the reset, which should be twice as long as the width of the set. No. Huh? Wait, what? Let me check what's happening here. Let's reset and don't turn on the dot. Okay. This is the reset. Do I need like as the measurements? No. Two volts per division. Okay, wait. Ah, can you focus? Okay. So this is the reset. Good night, Max. This is the reset every second. It's doing on the first output. So reset, column count. This is the first output. Seven column, that's right. Okay, I can show the code. How do I show the code? It's never the right one here. So this is the high side driver. It's sending the delay, and we have a clear, so this is floating, and this is a clear high at the, okay, let me try something else. I should maybe check if that thing still works. No. Black. Zero. The reset looks fine. Okay, let me set the dot. No, I don't add additional components. Okay, reset looks fine. I will just set the dot, the first one. Okay, let me check this. If we get a proper state there. Okay, so we want to set the dot high. We need a row. This one, no. Ah, it's hard when you are tired, isn't it? Oh no, this is I should remove this comment. This is already confusing here. This is not right. Okay. So everything is disconnected. Then we write 595 low side x1 enable, then write 73, which is the column y plus, okay, the row plus column count. That should be right. No, wait. Yes. This is what we expect here. Yeah, that's the set. But why isn't the dot moving? I don't see any current flowing. There might be like the connection might be not right or something here. Yeah, I will check if this connection is right here. This is like the green one was the first column. Oh, this. And the black one. Set the dot. Can you actually, okay. Set at dot means column driver pulls low to ground, yes. And row high is pulled high to VCC. Yeah, that's what we want. We can just pull everything out and test it with what we got here. So we have reset, floating, then this should be low and this should be high. So this should set the dot. And we don't get, oh, now we got it, okay. Oh, you didn't see. Okay, so it works this way around. This was right. Now resetting would be green to high and this to ground. Okay. Now we need this working on the breadboard. I have no clue why that isn't working. Maybe we need the 24 volts here, but that would be like really messy. Okay, let me turn that off. Okay, reconnecting it. This goes, the black one is the low, so it needs to go here. This is the high side. This needs to go here. And the column needs to go here. And now I try again. Might be that my wires are too thin and the connection isn't right and so on. Let me increase the voltage here. No. Doesn't work. I don't get why setting sets also the column high. It shouldn't. No, wait. Set the dots. Why do we get a high reading here? I don't get it. Okay, I will fix the wiring a little bit because this is like very thin wiring here. I'll turn this off so we don't break anything. And I think there might be basically a bad connection or the drivers won't work like that. Something's off right now and I'm not sure what. I will take this off and solder better pins there. It's very quick. We need some robust pins there. Okay, one more. Okay, again, we have the reset, which will be this one here. This is flowing to ground, which must be this one. Okay, good connection. Now we have the column, which must be connected to this one here. Also good connection. And the row, which must be this one. Okay. Let's start again. I will reset to 12 volts again. No, I don't see any current there. Okay, I will change the timings, increase them even more. Like reset 500 and set to 800, like 1 second. Where do I get 12 volts? Yeah, that's interesting, isn't it? I will check again. Okay, I don't see anything happening here, but we can test. Okay, this is... I get high at the low side row, which is okay because it's the dot is reset and we should have like current flowing, but I don't see any current flowing there. It's strange. We have also yeah, this is the high, I think this is the reset high. 800 milliseconds, that could be that. Yeah. I will show on the oscilloscope. This is 800 milliseconds reset delay. And this is at the wait. Row high side? What? No. Why do we get reset delay on the row high side? We shouldn't have anything on the high side here. This is the high. Wait a second, there is something wrong here. Reset delay. Why is this high? Oh, maybe we switched. No. We tested it. The blue one. No, I'm setting resetting again. So I show the screen. I'm setting resetting again, and I'm seeing on the blue wire, which should be the row high, I see the high side signal. Let me stop it. That's like for 800 milliseconds, we have, what is the roll? 200 milliseconds, yeah. I see on the high side of the row, there is a bug in the code. That's impossible that we get on the high side anything. because the reset, okay, I will reset, only reset, not set the dots. Let's try again. Because this is set, but this is reset. Reset set delay, no. Okay. We should only see a reset. Okay. Now we see 0 here, which is all right. We should see why do we see a set signal here? Huh? It's like inverted or what? We have only a reset. But I see 500 milliseconds delay. That's actually like 500 milliseconds. The reset delay, let me check. Oh, no. Okay, that's right. I changed it like that. Sorry, my confusion. Okay, again. Okay, again. This is only reset. The reset delay, this is what we see, this high signal here, 800 milliseconds. This is the column high. And this is the low side, which also shows high. Oh. That should be low. Oh, let me check something. We have 2 ground pins and I only connected 1. Let me check something. There is a second ground pin and I'm not sure if we are doing something wrong here by not connecting that one here as well. I thought they were connected internally. Is this the right one? Let me check. Yeah. Oh, we have 3 grounds. Do we need to connect every one of those? It seems like there is something really off. No. Still the same. Captain, we need more ground. Yeah. It's the same. I get on my low side, I get a row low, I get a high signal. Like I mean the coil is reset. There is like no. This would be only true if we get... Oh. Do I have a like bad ground connection here? Maybe the microcontroller needs... We have like connected ground between the microcontroller and the... Might be that the problem? Do we need to drive it from the same source? Yeah. I never see any current draw when I use the circuit, but when I connect it directly to the flip dot, I see current draw on my power supply. I'm suspicious that it has something to do with the microcontroller. I might want to run it from a power bank. Let me check if I can do that. If I can find it, though. Don't I even own a power bank here? This is so tedious with me. Yeah, it's probably in my jacket. I'll be back in a second. Okay, it's not in my jacket. I take any idea now. Oh, that might have some power, but I'm not sure. Probably not. No, this battery is dead. I don't think I have a charged one here. Ah. All ground must be connected. Okay, from battery, behavior is the same. Doesn't change anything. If I run it from a battery, I have no clue. Okay, I have all grounds connected. The problem is, I don't know what the problem is. Why do we see high there? Yeah, it's split, but I'm only using 1/2. So, or is it no. Okay, let me check something. So I see high. This is my pin here. This is my low side row, and I see high there. Let me check if I disconnect the flip dot, if I still see high there. I don't. So it's coming from here. So actually, the current is flowing completely through. That might also happen in the case oh yeah, it's not pulling it low. Yeah, that's right. That's the problem. So let's check. Oh no, this is serial. This must be low. Okay, how do I check if the serial... Is there... I can test it with a resistor now. I will use a resistor. I'm not sure what value this is, and I will basically pull it down, pull the resistor down, or try to pull it down, and see if that helps. No. That thing doesn't work. We drive it from 3.3 volts. Should we try to drive it from 5 volts? Because that might be an issue. But I'm not sure if the signal is accepted. You remember we had the problem with the... Okay, I try again. So we might need like a level shifter in between. No. Back the LED between 3.3. Okay. Yeah, LED. Where's my LED? Oh, where's the LED? Oh no. Where's the pink LED? I lost it. Here. Okay, I got it. This is 3.3 volts and ground here. Oh yeah, that's a good thing to test. Okay, we don't see anything there. Nothing happening there. Okay, let me drive it from 3.3 volts again. Do I have it put in the right way around? I need to test. Oh, if we wasted the time with like a buggy code there, I will be really sad. Okay, LED doesn't turn on at all. Does it turn on when I... Yeah. So this should be... We don't have a ground on our drain, which is drain 4. This is pin 14. Which is the right pin here. Yeah. 4, and the code says we have reset. Y column count What's missing? It might be the problem. Should we try to like level shift or anything? It doesn't change if we drive it from 5 volts. I tried. So let's do it 5 volts. Oh, you are right. Oh, this is, oh. You are right. So I'm setting currently, I'm setting not the fourth one, I'm setting the third one. Yeah. Let's check. So it might be this one or this one. Yeah. I'm so stupid. Oh, Fruchtzwerg. You made it. You are the stream master now. Uh-oh. I just shorted my power supply. Thankfully it was only like the real output and okay, yeah, let's do it right now. It was a good call with the LED, testing the LED, and here we go. Deep. Okay, let's change the delays again. Reset delay, let's set it to 150 milliseconds to set delay, because we don't want to like burn anything here. The pink LED saved the day. Okay, let's reset it. Or let's check it if it's resetting. Oh yeah, we get current. Yeah. Okay. 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 Highly anticipated and highly deserved. And highly probable for like short coming in. Let's activate the flip dot. After 6 hours and 53 minutes, so we are working good 6 hours on that. It's not resetting. It's too short to reset, probably. Yeah. Let's try 200. Or higher. No. Okay, we turned it on. We didn't turn it off. So let's try higher voltage. No. Maybe higher current, but 200 is enough. Should be enough, though. Nope. It won't turn off again. Uh-oh. We probably destroyed already like one of the drivers. Scope. Okay, I turn down the current again. Okay, so what I see now is we see only like the reset. I see only like every 3 pulses. So it might be that the IC shuts down. Let's see if we can actually. No. Now. We can only see it now and then. Here, there it was. It wasn't good enough to like invert it. We need this one to power. This is column 1, and this is row 1. Are we still in the why isn't it working state? Okay, so we have some like strange behavior state right now, and I'm not sure why. It seems like we don't have enough juice to flip it. What do we do here now? It won't reset. It turns on, but it doesn't turn off. If I help it to reset, okay. Do we try a higher voltage or current or what? It doesn't look like it's broken. It's really like... Okay, now I might really break it. I don't want to. Different dot. Okay, I can add some dots. Check what's coming out of the IC, what happens to the load. Can I probe the... I don't need to probe the coil at... Oh. Yeah, more or less, it's a half bridge. It's not pulled down. It is in some cases. I see like a behavior, can show it on the scope. It seems the IC is a little bit confused sometimes. I mean, I use like super thin wires. It could be like also the issue. So the high ones are where nothing is happening. We get only the high side, and now we have also the low side. That will increase the reset delay to 100 milliseconds. Okay. It's pulled low, but we have like a substantial resistance somewhere here. Okay, let me use 200 milliseconds. Okay, nothing, 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 low. But not really low, low. It's like current limiting. It's like the IC is current limiting. Or, okay. Let me try to power it from 5 volts. How is that? Oh yeah. 5 volts is like, works better for pulling it lower. Sometimes. But it doesn't get the signal right. I don't get it why it doesn't reset at... When do we get a point? Ah, I need to do this level shifting. Ah. Here. There it was, but the dot is still... Yeah, turning off takes more current, I think. Okay, I will add pixels. Let's stop it here. I will add the 4 rows. That's like only like a few wires we need to add. We'll turn it off for now. And then we should also try to get a level shifter. I might have one somewhere. Yeah, it turns off the complete column, but we have only like... Oh. Oh, yes. Oh, yes. We need like a lot more of current. But I don't know if the IC can do it. We need 16 times the current. Sixteen times the current or higher voltage. Oh wow, okay. Let me try some things. But the other oh no. Ah. It's a hard one. It's a really hard one. So we get really like headache with this one here. But once we get this running, it should work. I hope the ICs will be enough there. Or we need like a MOSFET here. Should we try a MOSFET? Or even better, let's try relay. How do we? Okay. Yeah, but we should switch to a MOSFET. Do we want to like? How do we like? Do we need like some kind of a relay? Yeah, but it's really like super slow. It should work with a relay, though. That's the easiest way. This is the easiest way also to set up to find out if it's working. I will add the wires now since I changed already the setup here. And then we will, wait, screen capture, we don't need to see that. A single MOSFET, but how do we drive the gate? We need like some kind of okay. You think about how we want to drive it, and I will solder the wires here. Oh no, I will just take a module for that, for the relay. I have like a ton of modules like that. This is like the simplest one, I think. This will also work from 3.3 volts. Or I take like one of my MOSFET drivers that I used for the solenoids. A solenoid will be very slow though. We can do it like a temporary solution. Okay. This is the 4th row. Oh, I burnt myself. Accident counter reset to 0. I mean, days since last incident. Okay, now I need more columns. More columns here. Okay, 4th column. I bet I will still be soldering here when people wake up and go to work already. But this is my work. This is how I live. Ah. I try to solder on some pins so it's easier to use with the breadboard, but I need a third hand somehow. Ah, where's the blue tech when I need it the most? Here, helping hand. Come and help me. I'm soldering it to the pin header and then pull the pins out afterwards. I need a little bit more. There were 2 more, I think. No, 1. Okay. 1 more. And then we have a 4x4 display. And then the area is growing really fast. Unfortunately, we don't have enough ICs here. I might have some, because these are also used to drive like LEDs, and I need to check, so we might have some on stock. Might not be DIPS package, but I think I have some shift registers here. Okay. Plug it into the breadboard first. Yeah, that would be a solution. So, do you have... You can use to drive gate with 12 volts if you don't have a logic level FET. Ah, what's the... Oh yeah, drive the... Oh yes! Yeah, that would work. Sorry to hear, Christian. Okay. So let's... let me check if I can try the MOSFET first. MOSFET solution, not MOSFET. I have another thing. Solid state relay? No. Okay. This is our temporary solution. Do you remember this one here? I used this for my devices already, and we got here DC plus, DC minus, and we can drive a lot with that. I take some thicker wires here, take some substantial solid wiring. This solder job is like terrible here. Here's some stains, but that will work for us. We need to change the code. Reset. We need a new reset pin, which will be oh. I need a flathead screwdriver. Hä? Okay, that one works. $27 I take. Oh no. 20. Yeah. No, 27 is used already. Okay, 26 it is, or 33. Okay, I take 18 now. 18. Okay, pin 18 is now the reset pin. Yeah. And let me show the code. And now whenever we reset is I hope it isn't inverted. Column reset. Oh yeah, we need this one here. This is what we need, I think. Let's see. I need another ground wire here, which will be this one here. You can't see anything, can you? Ah! Oh, is this even right? Oh no, this will power. Hello, Michael. Ah. This should be driving. I'm not sure if this one is powered. DC plus. Oh, I can't use this because we don't want to drive it high. Good night, Quindo. This is not the right one. This is not the right one. Because this will always drive high. Like, oh no, we don't need to connect it. No, it's all right. We can connect it to the high side, but we won't connect anything there. Okay, ground. Sorry, I'm confused. We only need to connect the black one there. And the positive one, which will be only to drive the MOSFET, though, here. We need that one to drive the MOSFET DC. And this one will you drive the current. I might need a thicker wire here. This is like super thin. I don't know if this works at all. Okay. What did I do? Do I do anything? Oh, reset pin. Huh? You can't just connect both the wires together. What were row wires? What do you mean? Okay, the reset signal here. Beep. Can you see it? This is our reset signal. I have not connected both row wires together. Okay, moment of truth. Even though nobody is watching anymore, we have black connected. Then we need to connect this dot here. Okay, I need to be careful. I will just don't want to short anything here. Okay, this is the first blue wire. Blue wire goes here. This is the row. Yeah, I think this is right. And column is going here. This is our half bridge. Second one. Ah. Okay. I'm not sure. I will probably not work through the night. I just want to see the dots flipping, and I might to continue since I have it's a one-day project, probably not one stream at this point, but let me now turn on the power and see if everything like magic smoke escapes. I pressed recording. Let's see, turning power on. Yeah! 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 Friends, this is a flipping dot. And we just needed an extra MOSFET board here. This is our goal. Let me change the goal. So, what do we need? Driving.mcu. Next goal, many dots. Let's drive many dots. Here. Sorry, I had total power on it. Aaron, it's the right time. Do you see the flipping dot? I turn off the music again. We have a flipping dot. And the best part is that I already connected 4 times 4 pins. So we can do like a few more. We might even be finished with like a rudimentary oscilloscope if I just connect the remaining wires, because we have only limited count of outputs here. We have like only a few drivers. You love the sound? ASMR, flip.asmr. Spectrum analyzer. Oh, you can, Christian, you can suggest it for the next time. Just be on the stream next week on Wednesday. Is it Wednesday? Yeah, every Wednesday, I think. I try to do it every Wednesday, though. Okay, let's try to drive. I will code a little bit. Oh, okay. I can turn on, I even recorded the right moment. Ha! This is cool. Yeah, that's cool. We did this circuit from scratch. Let's code a little bit. I will leave it there. You can watch it. Stress testing, and I will add some code while we watch it. Watch it flipping. Like oops. Let's try to turn on every single dot. Okay. Deploy. Like every single dot of the 4 times 4. Okay, we need to delete every column. So we reset. And there might be some troubled columns that need a little bit more timing here. Count X. Oh, that didn't work. FD reset. Yeah, but that didn't work. What did I wrong here? Reset. Reset column. I also need to adjust this one here. Set delay is like 60 or 70 because thank you, Leo. Oh, that's like really slow now. $60 might be, but why is it not resetting for the other ones? Let me just try to reset only first one. Okay. And the first dot is like really stubborn in this column. Maybe 70 milliseconds. No, this one is stubborn. Stubborn one. No, that's broken. We saw it flipping once, but not since then. Okay, why is the reset not working for if I use it like multiple times? Maybe we need X short set delay, no, reset delay. Let me check it. Reset delay is here. Oh, my Arduino window is really small. Here. There seems to be like a delay needed, and I don't know why. Let's do it like that. Flip smoked. They work sometimes they don't. I don't know why. I saw that one working already, but that one is also a little bit stubborn. Oh, wait a second. We are driving it at 12 volts. Let's try. Higher voltage doesn't work. Oh, 24 volts. Okay, 24 volts it is. Yeah. Oh, we might even improve the speed now. That's so cool. Oh! Stubborn. Ah! Let me change the current to 400. Yeah. Now, sometimes it fails. Okay. Let me check if we can change the timing, reset delay, and set delay to 50. You can smell it already. Okay, let's leave it like that. I like the speed. That could work with a waveform. Yes, yes. I love it. I love it. Okay, okay, okay. Friends, we are run many dots. 16 is not many. Let's use every single. Okay, let me check if I have drivers. I have more drivers like that. Let me check that. Shift register. Oh. Do we need shift registers or do we need... No, we need the other ones. I even found a... Oh, wow. Rectifier, PMOS. This is somehow stuck here. Okay, let me check what I got here. So what we are lacking are drivers, the high side drivers. And I found some Maxim 7219. Then we have uh, 74HC. What is this? And these are unfortunately only surface mount. I can't read this. This is so small. What is? $595D. Okay. So look at this. I have a row of the 595s here. These are surface mount, but we need the other ones. We need to draw. Oh, we don't have so many pins. We don't have so many pins on the microcontroller. Okay, let's work what we got here. Lot of current. I don't care. This is cute. But we actually, I have some here. So what we are working with, this one, because I have those for LED matrices. 7. That might be only like Darlington transistors, not MOSFETs. Temperature? What temperature? Where? Temperature is good. Good temperature. (74HC 595s). Okay, what 595s exactly do you have there? You can expand using 74HC 595s. Oh, the high side, you mean? Okay, let me check that. I have here 74HC 595D. Coil's okay. Okay. I love it. I love it that I'm such a hoarder, a part hoarder. I bought these, you know, these are like 5 years in my, or even longer. I just bought every part that I thought I might need at some point. This is so crazy. My shelf is stuffed with those things. Okay, let's continue working with what we have here. I don't want to like start soldering here the surface mount components. We still have the potential for more stuff. We have 3. We need like 16 output pins. So you won't run out of, oh, it's also a shift register. You can, oh yeah. Wait, the 595 is the low side. I'm running out of the high side drivers. I have like 3 of the low side drivers. The 595s is not the problem. Because currently I'm only using 4. And I need 16 in total, which I have with 2 ICs. I'm only running out of pins and high side drivers. I would need like, I could use the 595s as shifters to drive more high side drivers. Okay, see you, Justin. Okay, we have only one chance to finish this. We use the remaining stuff here. Oh! With just logic lab, you can drive. Ah, okay. I don't know. Okay, let's focus on what we got here. How do I turn this off right now? Sorry. Oh no! And I disable this here. I need more pins. I need like a few more pins. I run out of pins. Hello, Simple. Yeah, we got this, at least the flip dot matrix to running to some extent. But we are running out of pins and ICs to drive it completely. I'm not sure how we're gonna finish that right now. But I made a promise. Okay, now I'm running out of colors for these jumper wires, so I just take everything I got here. Yeah, there is fondue left, but I turned it off. It's cooled down. I'm not gonna eat any more. Sorry. Oh, I need to shift everything even. Okay, let me check how many pins I got left here. What pins can we use on the D1 Mini? I need to check. Okay, here. Broken. Okay. Row IC, what? I could use like an extender, probably. IO extender. Whoa. But really, I just want to get finished with that right now. So I just take every pin I got on the D1 Mini that I can actually use. And I don't know what configuration. Do we like add only columns so we get a waveform? No. Yeah, I squared C could kill the code. Yeah, we need just this I squared C IO extender first, and I think there's a library. The code is easy fixable for that, I think. We just need to change the high side things. Let me check it quickly. Yeah. Like that. Oh, wow. Combine rows, at least everything goes now. Yeah, pins needed. Okay, let's check how many pins we got on the D1 Mini left. It's like, unfortunately, it's really cramped already. Everything is cramped here. So I got 26. VP. What is VP? I need more. I need clarification. What is SVP? I hate this when this definition isn't complete. I need more. More. Ah. Okay. Ah, VP is 36, that is not usable. VN 39 345 TMS TMS is 14. TMS can be used. It could have been designed using 7 pins. VP Vice President. Okay, this is SD. SD is flash, not use. CMD 11. GPS. CMD. Not sure if I will kill it if I use it like that. CMDs. This is flash clock data 1. We can use 0 on the other side, I think. 30. Did we use everything there? Yes. Okay, I have 4 more. On the other side, we can use, we cannot use those, but we can use TDO, which is GPIO 15. This can be used. Then we have, oh, that's really too few. Should we switch to this expander and then we have like right away 32 GPIOs? I have even more of those. I just need to change the address here. Oh, this is even already changed. Wow. Ah. Spaghetti, yeah. I think the expander might be a solution here. We don't need any speed at all, so I will just get the library. Let's get the library and test it if we can simply switch to the expander right now, because then we have like this whole mess gone here. It will be easier, and I can even use jumper wires that have female connect. Oh, we are lacking female to males, but we can just use them like male and female to female connectors. Wait, no, yeah, these are always all female connectors here. I didn't find my box with the female to male ones. I'm in a state where I'm really tired, but I think I will pass that. We can do a little bit coding. That's like auto drive mode here, autopilot. Okay, library. I'm asking myself how much the expander is able to drive. How much current does it provide? I don't think it will be enough. But I'm actually curious about that. Okay. Yeah, no, this is only 5 volts. PCA 9685. Which one is best? Pietro module library or the I'll take the first. No brainer. No, I thought just skipping the 783 using only those expanders, but I don't think they work with no, VCC is up to 5 volts. V plus is 6 volt max. Okay, so this wouldn't work. Ah. Okay, let's take an example here. Oh, I hate the name. Fabo. It's like ESP32lib. And if I want to, I would force everyone to install a specific library. Let's go with what we know. Adafruit, they probably have this as well. PCA. Oops. Or SparkFun or whatever. They're the common ones. 8.5, not 8.6. SparkFun. Oh, okay, let's take it. I don't care. Fabo. Fabo PWM, okay, examples. Where is Fabo again? Fabo. Oops. Oh, wow. Is there documentation? Because I don't see the address there. Oh. What is this default value? Is this the frequency? What is this? 40, okay. So we need to initialize it with specific address, and we need like 2. So one is with the address slave address register. Okay, now I need to check this 4, 5. Okay. I can use this Fabo thing, but I need to set the address right. So this is the default one, and I have a second one. I would say this is like IO 0 and IO 1 because I got +1. I think that is what I have here. Now I need to initialize. Okay. Set hertz. We don't need to set the hertz, but yeah, whatever. We want to use it with full drive setup. IO 0. What is this 300? I don't know what this 300 means. Set hertz. Yeah, whatever. I don't need set hertz. 1000 hertz. Oh. Okay, let's do an output whenever we didn't find it. Not found. Let's clone this. Shit again. Let's try IO1. Now, what is the I squared C on the D1 Mini? I squared C. SCL SDA, okay. 21, 22. Oh, I hope I didn't use it already. Yeah, I did. Okay, let's remove it. Everything. So this is these are all the 8 that I STL SDA 21 and 22. Do I have like male to female? No. Oh, this is good. 21 and 22. 22 is that one. SCL and SDA, okay. Now I need some power. I found one. This is ground. We need a ground there. Yeah, sleep mode. Oh, I can't find proper male to female wires here. This is so tedious every time. Okay, let's take a long male to male and some extensions. Okay, this is VCC and output enable. Okay. It's a little bit over the top, but I can now try if we can find actually the address now. Okay, these things lit up. It's 8 hours, yeah. I hope I don't run into the 24-hour reset. Okay. Oh yeah, I need the serial monitor. What is it? Oh yeah, it found both devices. Okay. So I modify the high pins. We don't have the high pins anymore. We have init. Okay. Okay, let's try if we can change the code. Oh, this is so sad. Change delay. We can enable. This is what we don't need anymore. I will just comment it out. And now FD reset, okay. Right high. I will change it. Abstract mode now. This is our new method. And we need to use this will be like very dirty. What is this thing? Duty cycle. It's 16, huh? And then what's the maximum value? Shame, good long streams. Yeah, but it's getting like dreadful now. It's like super long. Where's the long now? Where's the clock default value start? What is this default value? This is like not very descriptive. Default value is probably for the servos. (12-bit). So it's 4 times, that's 1000. Okay, default value is 0 then. And it's 0. We don't want like servos. We want 0 here. And 1023. Trouble keeping my... Oh, Fruchtzweig, good night. Thanks for the help. I will try to make it work somehow. And yeah, I guess it was a good try. 123 then. Oh. Okay. Let's see if we can use that. We can even use like init and then right high and then 0. Ha! This should do it. Okay. And then we only need to check what to change here. Init. Okay, this will be right high. Right high. It's the high side, is not specific. Column. Oops. And then right high again. Like that. Cool. The reset worked, so we don't need the right. This is unnecessary because we have a working reset pin now. And what we need here is this again, right high. And here again, and here we want that. Okay, so now let's test if we can make it work though. I think I will change the order because I need this one to be +1 and this one to be +0 because that makes more sense. And then we can try if that actually works. Oh well, where are my male to female connectors? They're all gone. Okay, I hope I get the signal here. Like pairs of 4. me show that screen capture. Okay, this should be the restore the state that we had before with all the yellow ones here. Let me check the yellow ones. Funny, this one is even not a male. Oh, I skipped one. Okay. Oh, let's turn on the power and see the magic smoke, shall we? If it even works, I don't know. No. There's nothing happening here. I'm still here, I'm still alive, but I don't see. Oh wow, this is like very bright over there. So I need to check what's going on over here. Hey, where's my multimeter? Okay, it does something, but why don't I see the matrix flipping here? Okay, oscilloscope started up. I will check. What do I get from this? Oh, that was sad. Oh. Hä? Okay, this is like, oh shit. Ah, I'm shorting my oscilloscope all the time. Not shorting, but yeah. Okay, I see like a high all the time. I might need to disable the power first, because it might be like wrong. And check again. We have 12 bits. Oh, that's like there is like really lacking documentation here. What is the max value? Is there a max value defined? No. This library is horrible. Ah! It's 12 bits. That's 4,000, not 1,000. 4896, 4095 then. Is that what I want? Whoops, what's going on? Okay. Okay, I check again. Nothing? Good morning. So how does this stupid library work? Min max value, but okay, this was found. Yeah, both found. Okay, and now what's the deal here? The library works with code. Yeah, but it doesn't say anywhere what's the max value here. Oh, here. 4095. Oh no, that's mine. Okay, that this doesn't say anywhere anything. I hate this library. I need the other libraries. Ah, I regret I took it. PCA9685. PCA9685. And I take one with good documentation. Here. Let's check that one here. Oh, this is complicated. Okay, this is a little bit too well documented. Let's see that one. Okay, I need to debug this right now. There's no way around. IO set value. I will check for this. We'll disable the loop. $4,005. Thousand. I don't see anything there. Strange. Oh, this is not right. Set, reset, right high. Then I will change. Wait a second. Is this like initialize with min and max value or what? What is this? No, the oscilloscope doesn't show anything anymore. This is like very, very confusing. So I don't know actually what's going on here. I have like a wrong wiring, or what's the matter here? I have no clue what is still going on there. Ground is still connected. Ah, man. This I/O expander is killing me. I had like a different library for that. I might even find it though. I used it for mallet, for my mallet spot. Let me check if I can find what library I have used there. So YouTube, bitluni slab mallet spot. There it is. Okay. Yeah, these are from before. Nothing changed here. Okay. I used Adafruit PWM servo driver. That's the one. Oh man. There. This is the one I used before. Okay, let's stay with the familiar things here. Oops. Why didn't they use the IC number in the description? Whoops. So initialization is IO, then set frequency. This is what I used before. It's quite similar. It's quite similar. Not sure who was inspired by who. And that's basically it. Yeah. Oh, interesting. There's like set PWM. I could use, I could check this if there is like basically an on-off version of that. Not just PWM, but oh, sweet, that's the one. Ah, this is good. set pin. Yeah, but there's also like lacking of information. Can I just simply set pin number value invert? What is the value? What does the value mean? It's basically it sets PWM to special signal fully on. This is there is like a special value. This is invert. Full invert, and is this default 0? Invert false. Yes. Okay. Then we don't need to set anything specific. Right high. And we need only right high, and then set pin, and then 1. Or no, 1 or 0. Come on. 16 data 1. Okay. Good night, Sniff. Oh, there's no test if that worked. That's a little bit sad. But okay, it's expected. IO begin. And there is also no init. Okay. Let me check that. Nothing. And that's What is going on? I can't believe it. You still live, Aaron. Thank you for mentioning. The batteries are basically dead. They are also quite warm, so I think. Okay, so what's happened is there is a pin, output enable, but this is the inverted pin, but it doesn't show on the board. And I connected it basically to VCC thinking it's like necessary, but I leave it floating, and now the signal is working with the I/O expander, I think. Yeah. Okay, so let me just turn it on again and we see what the result is. Let me show it. Okay, so we are basically back. Oh no. Back to zero. Yeah, still doesn't work. Now I can test this again. Okay. I need to check this. What is this signal here? Still need to test something. Somehow doesn't work, even though I have a signal on the output of the I/O expander. I will test the code with write high, and I will use okay. Oops. Battery died. Okay, I have like a dodgy duty cycle here. I have no clue. It's like almost zero. So I need to like change the code. It looks like it's still some kind of PWM and not like a steady high or low. Here's some code. Hello, DIY. Okay. Hä? That's strange. This PWM, I don't get like a full signal, even though I'm using the codes like they say. Okay. 0, 1. Okay. So maybe I can 24-hour live stream. Yeah, probably. I end up. So what I got now is like, this is what I should. That's like a PWM, but it should be like a steady signal. It should be like a steady 0. Or did I get it wrong? Okay. Set PWM if it's 1. Oh yeah, 0 to. It's like never really fully on or off, it seems. We have even to populate much more wires than this. Okay. Even though it's not fully turned on. Other fruit, what do they say? Okay, I used that. This didn't work. Prescale, right microseconds. Totem pole. I don't know what this means. Okay, yeah, really cool. I will just try again. And now we should hopefully see the dots flipping again, but I'm not sure if that works. I mixed up. There is a mix-up in the rows. Okay, expander works now. Where's the mix-up here? We have a mix-up in the rows. So rather here somewhere. Yeah, I found it. Okay. Push pull. Okay. Totem more mode. Not open drain. Okay. 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 I can remove that. And now we don't have the lack of GPIOs because I can extend this to fill the complete 16 drivers here. Not 16, we have 12. So at least we can expand it a little bit more. We need 2, so it's a 4 by, wait a second, no, 18. So we have 9 by 9. Oh, we need also to wire some shift registers. I got it donated. That was a generous gift from Jakob. Therapeutic, yeah. And also my power supply is switching modes in the background. I don't know if you can hear that. Oh, you know what? Oh, this is only a high side, no, low side. Yeah, no, we can't drive it using that one. Unfortunate. Okay. I don't even want to disconnect it right now. Okay. Oh, I even found the right time to stop it. Okay, I need to solder on more wires. To be able to address everything. But we have only of those high side drivers. We have maybe some more registers that we can use. I have, what is this one here? 2719. What is 2719? Oh, 7.2. Sorry, 1.9. Okay. Yeah. No, that's a display driver. That won't work. What is the SN? Ah, yeah, no, that's only the shift register. Okay, yeah, that's all. That's not working. Flip Master 9000. Yeah, I need to get more high side drivers. But let's connect the last ones that we got. So I need to check. We want an oscilloscope. Do we keep like 4 rows and basically the maximum of columns that we can get? Or what is the 18 6 by 3, or is there anything else? 9 by 2. Oh, we add it. We don't multiply it. So we need, let's take a look at our sketch again. So we need 2 of those high side drivers per column or per row. So we can only add, like we have here 25, so we can't even drive like all the columns, neither the rows. We have currently 8 used. When we add like the other ones, then we have 12 by 12. This is a 16 by 25 matrix. 12 by 12. Is this any good? Or should we rather use like 10 by 16? No, 8 by 16, sorry. 8 by 16, we could use like at least a part of that for an oscilloscope. No, we don't multiply, we add. It's like adding, not multiplying in this case. Because we don't need for each of those pixels take the row to row. Yeah, we can use like the columns, and we will hold it up sideways, and we can clear like the lines quite quickly then. So we get maybe a better update rate on that. Because I'm just thinking about where to add wires now. And the best thing, these are columns. So we need like 8 columns, so we can reset quicker and get a faster rate here. I will do that, yeah. Okay, now how do I move it without disconnecting everything again? Oh, no, I need to solder it to this. I will get my soldering iron over here, and we will do it here. What I am... There's a flip dot oscilloscope. Okay. Got the power supply here. I think we should be ready like in an hour or something. Shouldn't be that long anymore. We got the display working. Then okay, we got the display working and 8 columns. Okay, so I need 4 green wires. And now we basically need to solder some wires. Or we might want to extend also on the shift register, because we need low sides. Oh no, we can work with... Oh, 8 columns is easy, yeah. We need only like 1 low side per column. So we don't even need to attach a second for the configuration that we planned. We don't need even the second shift register for that. That's easy. Oh, I will share my screen with you, or the makings here. Okay, I got 4 of these, and I got enough blue ones. stripping the wires. I might want to detach the microcontroller. Oops. Just burnt cable here. Okay. Okay. That one fell off. What? No. So these are 4 more, and I will attach those 2 pins again. Ah. What is this? This temperature is way too low. Here we go. Something's off with this solder here. Hello, Emre. Ah. Paint is the best program, yeah. It's at least a program that everyone understands. Okay. Okay, this shifts everything over to here. Okay. Okay, so the columns are almost, oh no, it's like intermixed now here with that one. Okay. I detach it again. Okay. I also need like a cross connection. Let me show that. Between the high and the low side here. Yeah, that's terribly short here, everything. Okay. Okay, I got some guan. Okay. That should actually be now a few more. Should we try it? So hard not to, oops, not to melt anything here. Okay, I need to adapt the code, and then we should have now 8 columns instead of 4. So that should be easy. Okay, column count 8 and upload whenever I connect it here. Oops. Uh-oh. That didn't work. Something's wrong. Let me check. This is all right. This should be all right. High count is 8, low count is 16 now, or no, 8, this is 14, no, 16, let me try again. No. I rather stop. High count is 60 now. That's okay. Low count is 8. Is there a special reason for the fondue? No, it's basically I also need to eat something, and since my streams are so long, I'm watching. And thank you for the compliment. Okay. Oh, I need to connect that one. I didn't power it yet. Yeah, so basically here are some wires missing. Yeah, that can't work if we don't connect everything here. Here, there's complete wiring missing. Need four more. Okay, now we got it. This should work now. Yeah. No? Oh! Oh yeah. Oh yeah. Now comes the hard part. We need to add another 12 rows. Oh, I need to record it. Okay, Okay, that's quick now. Just add some more wires and some more jumper cables. This is like, I should basically submerge this thing in hot glue and let it cool down so it doesn't break when I move it. This is so cool. Oh man, I like it already. Okay. Oh, I need to drink some water. I deserve it. Okay. Now comes the easy part. Let's turn it off. We got 1 pixel there. The fondue is cold already. Sorry. I wasn't like very eager to eat much today. And I had also the Mettbrötchen before. Okay, let's detach that one because this is the one that we need currently. This is what we need. Oh, this is like super prone to be shorted if we just put it somewhere down. Detach it. And let's solder some wires. 10 hours. Oh. Okay, I have 8 here. Okay, I'm missing 4 more. Yeah. I need 4 more to get all what we want, what we need. I found 2 more. Any helping hands? Okay. ordering a ready-made PCB is probably way easier than soldering this whole stuff. Okay. Okay, I need 2 more wires. Blue ones. It's quite a lot, must admit. It's a lot of wiring. I think I will group those to the connectors by 4 now, so it will be easier, and I will leave the plastic on here. So I will leave it like that. Since I know the order now, it's like this, then that. I think it was, yeah. This is the first one, yeah. And the second one is this, yeah. Yeah, desktop autonomous robot. Sure. Would be way easier probably. Especially since I have the most, it for the most part. I have like an, did like for a small project, the Super Nintendo controller video. I made a small, like 2-wheeled controllable bot. It's very easy, and that actually could be basically extended. I don't know how we would do the vacuum part, but Okay, I have a broken vacuum, but like this, the small, you know, the vacuums that you use for the table, and I used many times as well. I think that it's broken because I must admit I used a higher voltage than the battery that was included. Now it's broken. I could maybe reuse the parts. Okay, the estimation of 1 hour might be a little bit optimistic. That I did like an hour ago. It's quite some wires to solder, actually. Okay. Okay. That's 4 of 12. That I can actually directly plug in. Yeah. That goes right in there. Oh. Okay, next 8. By the way, Aaron, it's all your fault. It was your suggestion to do this 1 day thingy. Now I'm stuck with my promise here. It was a great idea, just over ambitious project. No, no project is over ambitious. Okay, I maybe thought that this would be easier. It took us quite a while to figure out how to run it. And that set us off for a bit. But I'm willing to do it Really, I think it's doable at least to some extent, not like a perfect oscilloscope or something, but I think something like a multimeter could work. Like a super crappy one, but it could work. Even though it's not like that I need to wire every single pixel. Imagine that. It's only like the X and Y things. Okay, next 4 are done. Cool. Okay, 4 more, and this we can drive many dots then. And then we can extend it by the functionality. We need some kind of input. I'm not sure what kind of input we would use. Like a button or this rotary encoder would be nice, though. A little bit of code, show a waveform, just one input on the analog stuff. You can give, I can give you a MQTT or WebSocket feed to my multimeter. Really? That would be the easiest part, I think, then. But wouldn't you like to see an actual functional multimeter? Just a voltmeter, let's say a voltmeter. That's like an oscilloscope. We need like 2 modes. It outputs a JSON feed. That's cool. Seems to be a fancy multimeter. Hi. Okay. Oh, this is a little bit molten here. Ah, let's bend it in shape and be done with that. Oh, John Oxer. Oh, cool. Sounds great. Ah, okay. That looks like when I don't shave for a few weeks. Wow, that's hefty. Man. Okay. And we are not done yet. There's like, we need to connect. Wow. Okay. We still need to connect all those like 8 more outputs here. I don't know even how, because I don't have like these many. Okay, here we go. We need 4 and 8. And now we need a lot of these here. Oh. You developed a web UI as a red node custom node that displays a replica of the screen in the web interface. That's cool. John has the web UI in an OBS window. Oh, that's cool. I actually was looking for some example code how to develop an OBS extension, because it is possible, but I didn't find many like tutorials online or like simple examples or anything where someone did this before. Most of the people are using like web thingies that they just put in OBS, but I want to access the stream. So the resulting stream that OBS produces, I want to grab that and send it over UDP to an LED wall or whatever I'm building right now. And that's something that I would be highly interested in, but I didn't spend much time on researching it before. So that could be like a super cool extension. I will basically use all of my jumper wires for this thing here. Okay, this. Oh, am I recording? I am. Do not record everything. Okay. So this. Perfect. This goes here. Oh, I'm hearing the birds outside. Oh, wow. Ah. Guten Morgen, Sebastian. Breakfast time. Yeah, I can turn on the fondue again. You peeps are going to work? Or what's happening there? Okay, now we are at the second extension board. We didn't try that before. This is crazy. Ah. At least it's a little bit more organized when I'm using Dupont wires that are still in a ribbon configuration. Like this. Ah, now we got it. Okay. Whoop. Whoop whoop. Ah. This is an abomination of breadboarding here. This is still heating. How do I turn this off? I want to turn it off. Turn it off. I just unplug it. Screw that. Okay. Let's change. Let's change the count. Oh no, a whole mess here. We have now low count is still 8, but we have the row count of 16. Ladies and gentlemen, this is going to be crazy. Reset. Okay, row, column, low, high count is not 16 anymore. It's 24. Okay. Oops. Microcontroller not connected. Yeah. Wait. No. Okay, uploading. Okay, one is disconnected. Oh, something's going on here. Uh-oh. We might have shorts or whatever is happening here. Ay. Okay, so we have the first 8. Then you nerd. Oh, there is a broken pin here. Okay, this one needs to be replaced. And there is certainly something missing. And now I need to debug everything. I need a break for once. Okay, this makes sense. This doesn't make sense here. Okay, what happened to this row? The third row. I need this to find the source of this error. Okay, I found this error here. Uh-oh. Did I short something? Uh-oh. Let's disable it shortly. Ah! Okay, I found one jumper wire, which is a little bit... But what else is happening here that is causing problems? Stuff overheating or what? No. Okay, let's try again. No. I have no idea what just happened, that it stopped working all of a sudden. I mean, there might be an error in the code with the lines that we are still missing, but other than that, I don't see a problem here. Let me check something. Reset the ESP? Yeah, that could be a thing, but oh yes, I probably shorted something on the boards here. I will be just back in a second. Okay. It looks like Pac-Man. Yeah. No. Nothing happening here. These are like so many wires that I don't even know where to start. Oh, maybe this one here. It could be everything. Please don't let me scope again. Hello, Steven. Okay, I'm getting hungry. I need to turn this on again, my fondue. And now I need to find out what happened. What happened here? Is there a short? Somewhere. Oh, this actually looks really clean to me. So this is fine. This also looks fine, as far as I can see. Shift register, all good. Okay, power off, power on. Drawing too much power, do you think so? No, nothing happens. It's strange. It's like all of a sudden everything is... Oh, I scratched my desk. Okay. Actually, I have no clue what's going on right now. Oh, no, this is not the case. I'm suspecting some wire might have overheaten. So, too ambitious, you say. Oh, oh yes. Oh yes, I just shorted the power supply. That smells great. There is nothing. Okay, I have no idea. Yeah, it's flashing like super bright. I don't know, we had this before when there was something off on the board. We don't get any reaction here whatsoever anymore. Oh, I see. I had a disconnected ground here. But this is nothing. Oh! Ah, okay. There's still something in the code. It needed like a reset, a longer reset. So I suspect that we are missing something. We don't get the last 8. So the last 8 are on the secondary board here. The last 8 rows. So let's check again. Data I minus 16 and 1, and this is IO1. Hot glue. Okay, let me try something. When we, oh no, we can't change this. High count, row count should be 16. This is all right. It's like super primitive. If I... Oh! Houston, we have a problem again. There's something overheating here. I will just disconnect it again. Whoa! My spring just fell off. Let's overheat a little bit. Oh, my bread is dry. Dried. Oh, oh yeah. Can get some fondue. Oh yeah. Oh. Oh. A reboot Apollo, yeah. But this is not a very reliable oscilloscope if it always dies. Oh yeah, ferrofluid. Probably. Oh. I'm so hungry, this is so good. Oh! I'm still wondering why the second one isn't addressing well. Is there a secret in chaining those PWM extensions? Maybe I need to address it a different way. It must only hold up long enough to film bits and pieces of hype video, which makes it seem work. Yeah. Oh, I'm recording too much. What happens if I flip them? No. Nothing. No. I need some breakfast. Oh yeah. Oh. There's like some crust on top. I love it. Put the pink LED on a pin that's not working. Yes! Yes! That's the way to go. Finally a suggestion that might even work. So we need ground and a pin that's not working. No. That should be working, but it isn't. Let me show that. Here. It will flash from time to time when resetting. Wait for it. There it was. It is just connected with this connector that, oh, that cheese. It might be something with how it's addressed here. I'm checking and it looks promising. It's basically the examples on other fruit say the same what I'm doing here. Yes, I'm still going. Of course I am. I want YouTube to sweat. They still didn't enable this donation button for me. I want it on my channel, this, how is it called? Where you can do a like one-time payment for a video. "12-hour stream." Not yet, not yet. No. It's not many. It's only the half. I want the full width. Super thanks. We will see. 12-hour. Didn't I stream 16 hours already? It's not my longest one yet. Oh, the fondue is formidable. Oh yeah, recording. Yes, it's cut off. I think I won't be able to download it anymore or something. You can't rewatch the complete stream then. Oh, this is so good. Man, I must be really hungry now. Fondue cam, yes. Especially such long streams. It's very nutritious and tasty. It's very strong cheese. Like, it's Swiss, so my girlfriend doesn't like it. But she also doesn't like to go eating sushi with me. And it's very sad because I really miss eating sushi. I have to visit some friends to do that again. Mm. Okay, I finished this, and then we figure out what's happening there. Okay. Sharp memory displays. Okay. Here. Empty. Oh. Ah. Fresslähmung. It's a German word. Oh. I touched it and it broke. I basically touched like the LED, which has exposed contacts, and that broke everything. So no touching, please. No touching. Okay. Reset. Go. How should I make an oscilloscope where you actually touch everything electric with that? Okay. Let's take a look at the code. I need the code. Give me the code. What's happening with the code? Huh. I don't see it. I don't see an error here. Okay, I need to probe it. Okay. And it's gone. So let's take a look at the PWM library. GPIO test. I turn this off. So I'll be probing now this GPIO test here on what? Did it die? What? It's timing out? What is happening here? Dude. There's this one ground is always like disconnecting here. That might be an issue. Okay, now it's programming again. Okay, that works. this is 16, and we have 2 more. Oops, X. Ah. Okay, I check. Huh? Okay, that works. If I write right high, that works. But it doesn't work when I drive the display. Let me check again. Let me check to write 4 more. Stream already broken, or is there anybody? Huh? That should be high too. Aaron, you are working late or early. Hey, system. Oh, something seems broken because it should be. I sent right high and the LED, the pink LED is still lit. So like it's not even responding here anymore. Yeah. Yeah. I'm still going. I still have Still have to accomplish like the remaining rows on the dot display. So we got 8 times 8 working, and we have wired the remaining 8 here, but somehow the extension board doesn't like it for some reason. I don't get it. The extension board doesn't like it. Maybe power is dropping really. I have no clue what is going on there. Might want to add some power to it, but I don't know how. Oh man, no clue. No clue how to fix that. Yeah, I just ate it. Nope. It stops at this point. Okay, I will switch it with a different one. Here. Is it Thursday yet? Okay. Let's try that again. I almost killed the stream by accident. Nope. It doesn't help. Yeah, I can swap them over because they have like or I could basically place them here in between. But okay, let's do that. I clean this up a little bit. I won't chain them anymore. And basically plugged in like, oh no. Will that work? Okay, let's try something. Maybe we get power issues. SCL, SDA. Ah, but that, no, that's stupid. Okay, I try. No, this is the wrong one. I need that one here. Okay. God, that is like very convoluted, and I don't even know if I got SCL and SDA right, the right way around. It's always a gamble. No. 50-50 and I got it wrong. Okay, now nothing works here, or what? Nope. Now it's completely broken. 22, 21. What is SCL? Was